हरि करना।
Welcome to the second module of welcoming to the terminal world. So, the second module of this is Terminal Multiverse Bash scripting. Here we are gonna, so far we have covered the basics of Linux system and the command line. Now it's time to start coding. So here we will discuss the basics of writing shell scripts, and you for this you need to know the following basic concepts that you see on your screen before you can actually start writing your own shell script masterpieces. So if we begin, what is a scripting language? A scripting language, or just a script language, is a programming language that supports the writing of scripts. So then what will you get it by writing the scripts? What's the benefit for you? A scripting language provides a higher level of abstraction than standard programming languages. Compared to the programming languages, scripting languages do not distinguish between data types such as integer, real values, strings, etc. And the most important point to be noted down is scripting languages tend to be good for automating the execution of the other programs. For example, analyzing data, running daily backups, this kind of information, these kind of activities. And they are also good for writing a program that is going to be used only once and then discarded. And now a script is a program written for a software environment that automate the execution of tasks which could alternatively be executed one by one by a human operator. So the majority of script programs are quick and dirty. So where the main goal is to get the program written, get the program that's written very quickly. So now let's jump into the rules to write your first script, and that's it. So a shell script, basically to place a shell commands in a text file, first you need to use a text editor. Basically how to work with a text editor in Linux. This concept we have discussed just in our last session, the first module of welcoming to the terminal world. You just get back to that module and have a look on that. Okay. Now, so we have to use a text editor to place a shell commands in it. So now to create a file and then enter the commands into the file, we can use any kind of text editor. It could be a Vim, Nano, whatever you like, Geno, so whatever you like, okay? And a shell script is basically a file that contains ASCII text Now the most important point which should be considered when you writing your first script is, when creating a shell script file, you must specify the shell you are using in the first line of the file. What is that? The shell. Which shell you want to use, that should be specified in the first line of the file. The format is, you can see that on screen. It's a shebang, then bin and bash. So this is the shell you want to use. So that should be the first line of your script. Whatever script, how much bigger script you want to write, it doesn't matter. This is your first, this should be the first line of your script, the shebang. And then binary directory, in that you have a bash utility. You go and get it and you execute your file from there. That's what you want to tell. Then the majority of script programs are quick. As we know, as we have discussed earlier, the majority of script programs are quick and dirty. So basically there are a lot of lines of code to be written in a text file. So it's better you design it very well. You use some commenting and this kind of information. So that's what we are discussing now. In a normal shell script line, the pound sign is used as a comment line. A comment line in a shell script isn't processed by the shell. However, the first line of a shell script file is a special case, and the pound sign followed by the exclamation point tells the shell what shell to run the script under. So yes, you can be using a bash shell, and you run your script using another shell. It doesn't matter whichever shell you can use, but that's the way. You need a pound symbol to comment the thing. So because it's dirty, the shell script is dirty, the huge amount of lines are involved. So commenting is very much helpful in distinguishing the modules of the code in that script. Then after indicating the shell, commands are entered onto each line of the file, followed by a carrier's return. As mentioned earlier, comments can be added using the pound sign. So now, how will you execute your first script? There are different methods, and this is the normal way of executing your script. The path is an environment variable that we have seen in our earlier sessions, earlier videos. The path environment variable is set to look for commands only in a handful of directories to get the shell to find the script. For example, the script name you have written as test1.sh. Now, to get the shell to find the test1.sh script, we need to do one of two things. The first one is add the directory where our shell script file is located to the path environment variable, and then you can use echo and then dollar symbol and then path, because this path environment variable we have given the directory of the shell script file, so automatically it will run the file. And second one is use an absolute or a relative file path to reference our shell script in the our shell script file in the prompt. To reference a file in the current directory, you can use the single dot operator in the shell. Anyway, we are going to execute our first shell script within a minute, so you don't need to worry. So just brace yourself for your first shell script. So then the shell found the shell script file, because you have used two methods. Either of the method will bring the shell script to the shell. Once the shell found the shell script file, but there is another problem. What is that? What is that? The shell indicated that you do not have permission to execute the file. That's what. So a quick look at the file permissions should show what's going on here. So what will we do is, uh, obviously we will get an error, a permission denied. So now we have to modify the uh, fault. So once the fault has been modified, then we can actually execute the shell again. So what will we do is, let's get into, let's dirty our hands, and then let's write our first shell script. I think this is not first for me, but this is first for you. Yeah, let's do it, and let's see what challenges we are gonna face with our first shell scripts. So I'll say vim, and then first script dot sh. Yep. So let me go into its, I'm in normal mode. Let me press I and enter into insert mode. Yes, I'm in insert mode. So now, what are the golden rule of writing a shell script? We have two golden rules, and first one is using a shebang, and mentioning the shell which you want to use, and then using comments. So let's begin with the shebang, pound, and then exclamation mark. Then I want to mention about the shell that I want to use. So that bin and then bash, this is what I want to use. Now I will give you a space, two lines of space. Then I will comment. I will enter my first comment, that is, this script displays the date and who's logged on, and also prints system info. That's what is this is gonna do. Okay, so now let's begin our first script. So to make it look beautiful and elegant, what I will do is, I will decorate uh, I will decorate around each command. So first decoration begins echo, and I just want to print this line. That's it. And after that, I want to type, I want my script, my system to print welcome to the bash world of dash dawn. Welcome to bash world. Then again I'll close an empty space. So that's it. This is your first three commands. Now after that, I will add one more command, one more comment, saying that this, what it has to do is check who is the user. This module, the next module is for checking the who is the user. So again, I will decorate first echo, and then a line, then echo one more decoration, space one more decoration using colons. Then who is the command to find out the who is logged into the system. Then again echo this guy is the user of the system. Then closing with decoration again. That's it. This is our second module of our first ever script. And then the third module checks the date. So echo again begins with the decoration. Echo again goes with the decoration. Then comes our main command echo the date. It's like commenting, but it prints what is going to happen. It echoes the line that I want to print. So the date of the system is, and the actual command is date, then again echo, and then I have decoration again. And then the third module is also done. Now we will go for the fourth module, that is to check system uptime. That is to check system. It checks the system uptime. Again decoration goes, okay, then echo the uptime of the system is, just a minute, I will add a colon, and then actual command, that's uptime, and then decoration again. This time it's colons. Yep, done. So now the last module of this, no, let's see, the next module of this is memory utilization. It checks memory utilization. Checks memory utilization. Again, let's copy paste the decoration, and then add a information memory utilization. Memory utilization is, and the actual command is free and -m. It's option, and then close this with echo decoration. Then the modules are done. So finally let's put cd and then close it with line. So our first script is done. I hope you are following me and you are also writing the script along with me. So press escape. Now it is an extended edit mode. Then click shift plus colon. So here you can enter W and Q and then press enter. That's it. Your first script is there. Here it is. Here is your first script. That's a first script.sh. So Now let us try to execute this and see. So basically there are two methods, using path environment variable, or second directly giving the absolute or relative file path with dot. So I will try to use a second method, dot, because it's in this directory, because present working directory is this tmp scripts. So dot and then forward slash and first script dot sh. So what it is saying, bash first script dot sh permission denied. That's what I was saying. So here when I try to execute the file, the shell indicated that you don't have permission to execute the file. So now how can we solve this? So then how can we execute the file, execute a shell script? How can we do that? So for that, what will we do is, first let us have a quick look at the file permissions and see what can we do with and what's going on there. Okay, so for that, ls lrt grep, that's it. Here is your file and here are your permission. The first character indicates that this is a file. That's fantastic. Then a owner has a read, a write, but no execution. Even the owner doesn't have permission to execute. See, that is the condition. And then group members has only read permission, no write and execution, whereas others nothing. But here shell, owner is not going to execute. The shell has to execute because shell comes into others. See this part, the last part is these are the permissions that belongs to others. So shell has to execute this file. Shell is also in user and shell has to execute this file, but that to happen it should have a execute permission. It neither have write permission nor execute permission other than read permission. So what can we do? So how to solve this issue now? That's my question. Take your time, think and get back. Okay, so now, so what happened when this file was created? The unmask, the value, so was determined the default permission settings for this one. So because of this default permissions, it has given only read and read permission for the others. Now what we have to do is we have to unmask these permissions and we have to give execute permission for the shell, because shell comes into others. So you have to give execute permission for the others so that it can execute your file. So let me do, if you remember and recollect, we have discussed about the file permissions in our previous module. You just get back to that module and look into that. So we can use chmod, and there are two ways of doing it, either using letters or other ways numbers. So we will do with the letters first. O means others and add, plus means add a permission to others, and then what is that, execute permission plus x. So O plus x, and file name is first script dot sh. Now let's check again. Here it is. So others, shell comes into others, so others got execute permission. So now let's execute and see what's gonna happen. Here it is, dot forward slash first script dot sh. I am going to execute. This is our first script and this is the first time our execution of Linux script or bash script in Linux. Let's see what's going to happen. Finger crossed. That's it. You got it. Your first script has been executed. So let's go up and we will look into the script. It's looking fantastic. It's looking beautiful, elegant. I love it. That's how you have to design your script. I designed my script such a way that, because after that, if I want to look back to my script, it should not look like dirty and ugly. So, as you like your girlfriend to be beautiful, your script should also be beautiful, my friend. So that's how you have to design your scripts. So this, of course, if you go through the script once, uh, this is what our first echo. Welcome to the Bash world. Then after that, we want okay, user, that we missed, maybe the command. Here only we got the echo. There is no actual command. And then we asked the date of the system is this. Then the uptime of the system is this. And memory utilization is this. And finally we closed it with a line. See one more time how nice it's looking. That's how you have to design your script. This is my own design. I like to design scripts well so that it looks well. I hope you got it, and you also written your first script with me, and you also executed your first script with me. I hope you enjoyed it. Just running individual commands from the shell script is useful, but this has its limitations. Often you want to incorporate other data in your shell commands to process information. So you can do this by using variables. Variables allow you to temporarily store information within the shell script or for use with other commands in the script. So basically this slide shows you how to use variables in your shell scripts. So it begins with the first point of it is a variable is named object. That's it. It is a named object that contains data used by one or more applications. And second point, there are two types of variables. It's common even in other programming languages or other systems also. It's common with every aspect of programming languages in software industry. uh, there are two types of variables. So one is environment variable, and second one is user defined variable. So and it can contain a number, a character, or a string of characters. So now first let us look into environment variables. As we have discussed about environment variables in our earlier session or slides of this module or this course, the shell maintains environment variables that track specific system information such as the name of the system, the name of the user logged into the system, the user system ID called U, capital I, capital D, or the default home directory of the user, and the search path used by the shell to find programs. Even in Windows we can see, if you are machine learning guy or AI guy, you might have installed Python. So after installation of Python, while installing the Python, it will ask at the initial step, the first step of installation of Python is to check the path, check the path while installing the Python. So that's what, in that case, the Python's binary file, the Python's binary file address or path will be attached to the uh, Windows command line, environment variable. Environment variable name itself is path, capital P, capital A, capital TH, path. So when you say Python in command line, Windows command line, automatically it brings up the Python. That's how it works. That's how an environment variable helps you. So you can display a complete list of active environment variables available by using the set command that we have seen earlier. If you click a set command, it will show you the complete environment variable that are available for your system. So now you can tap into the environment variables from within your script also by using the environment variables name. But the most important thing is, the environment variables name should precede by a dollar sign, should precede by a dollar sign. So so this so now let's demonstrate this using an example. Okay, so let's get into WSL to do the same. So I'm just dragging this a bit right side. So I will write the script file using Vim text editor, and the name that I want to give is, this is second exercise, and then in second part it's the first exercise of it, so I will call it as environment variable dot sh. Okay, let me click on it. Yes, this is the code I just want to write. Now just go through this code one by one. First, it's very important for us, shebang, then the shell that you want to use, the shell that you want the following commands to be executed. So that part is done. So after that, a the comment I gave, display user information from the system. That's what I want, because here I want to use all environment variable, only environment variable. So as you know, I like decoration, so it has begun with a decoration, and then here where we have, so echo user info for user ID. So user, capital U, capital, again environment variables in Linux are capital, only capital. So here it's an environment variable, the environment variable preceded with a dollar symbol, so I think it works. Then I want user ID information, UID, so I use dollar UID information, and I want home, dollar home. So three environment variables, and then a complete a lot of decoration and preparation around it. So let's give WQ and click enter. So but you know that if you don't give the permission uh, for shell to execute this, it is not possible. So that is the reason I'll give chmod and then wo plus x, and file name is 20 environment variable dot sh. That's it, the permissions has been given. So now let's execute it and see. So 20 environment variable dot sh, that's there. Yep, here it is. The first environment variable says user information for user ID is root user. Of course I'm a root user here. And the second one says UID. Of course, the root user ID is 0, that we have discussed in our earlier sessions also. And then what is the home address of root ID? Home directory of the root user is /root. I think with this I am able to successfully demonstrate the environment variable usage and purpose and application. Is it clear to you all? Okay, so now let's move into a second type of variables, that is user variables. So in addition to the environment variables, a shell script allows you to set and use your own variables within the script. These are called user defined variables because you define these variables. So setting variables allows you to temporarily store data and use it throughout the script, so making the shell script more like a real computer program. That's what we do in Python. Am I right? Yes or no? Of course your answer will be yes. That's the simple question. Okay, so then values that are assigned to user variables using an equal sign. So, and one more important point is there should not be any spaces between the variable and then equal sign and then the value. There should not be any space between any of these entities. So what else? Example you can see is variable 1 and there is no space, equal there is no space, and value that is attached to that variable 1. The value that has been assigned to that variable 1. All are without any uh, spaces. If there is a space, it's a Linux. It will consider it in a different way. So that's why don't give space. The shell script automatically determines the data type used for the variable value, and variables defined within the shell script maintain their values throughout the life of the shell script but are deleted when the shell script completes. So next let's look into various rules of writing or assigning these variable names. And so because you are the one who defines the variables, you are the one who gives the names to these variables, so we should know what all rules. If you are a machine learning guy, an AI guy, or data scientist, you might have worked with Python. So by and large the rules are similar as Python. So the first rule, variable names must start with a letter or underscore. That's it. It's as simple as it is. A letter or a underscore. Either of this. That's it. If you try to put any other aspect, any other character like number and special characters, it doesn't work. It throws an error. And numbers can be used anywhere else other than starting of at the beginning of the variable name. And do not a big no for using special characters such as at the rate of, pound, and percentage symbol, a dollar symbol, any kind of special characters, a big no. And then always remember, it's a case sensitive. Then to reference a variable, it could be an environment or user defined, you need to prepend the variable name with dollar, as for example, as in dollar variable or dollar path. Here dollar path is your environment variable example, and dollar variable is your user defined variable. Whatever it may be, either it could be environment variable or it could be user defined variable, but the dollar should precede the variable name. And it's good practice to protect uh, your variable name within braces, within curly braces or curly bracket, within curly bracket, such as instead of directly putting dollar and then path, you put brackets so that you can protect that variable when referencing it. Okay, so now let's do a small exercise on variable rules. Okay, let's demonstrate the variable rules and their protection. So let's get back to this. Let me clear the screen first, and then I'll move it on left side of it. Anyway, it's nothing much to visible here. Okay, so let's use vim again. Vim, and then this is 2_1, and then variable rules.sh. This is the name I want to give, and let me click, and this is the script I want to write. So as usual, let's begin with the shebang. Then this is our shell. Now first module, let us validate the variable rules. So decoration, and after that allowed variable name pattern. So that's what we are checking here. So first if it starts with a letter, there is no issue at all, so that's what it is. And then second one is also started with letter and number is in between, no issue at all. Third one is absolutely fine, and the fourth one there is an underscore between the letters, and fifth one started with an underscore, but still it's fine. It's as per the allowed rules, variable rules. So let's after defining these variables, let's call them. Let's call these variables here. So echo, and I just want to protect each and every variable. Of course, even if you don't protect, still it's fine, but if you protect, you can actually differentiate from the other names that are present in that script. So here I have protected var1, all other variables I have mentioned here. And the second module for us is, yep, I'll just make a distinction. Yes, here it is. The second module for us is it is not allowed pattern. So just give me echo, and then space, echo, space, echo, space. That's it. Okay. Now this is not allowed variable name pattern, so I started with one, a number, that's not allowed, and then a special character, that is also not allowed. Dollar, that's also not allowed. In between I used a special character, that also not allowed. I have called these variables here, and let's see what's going to be the result of it. Okay, so and here, so let me click on escape and enter into the extended mode and type WQ and press enter. Of course, if you directly want to execute this exercise, it's not possible, because you have to give execute permissions to shell. So for that I will use chmod and wo plus x and 2_1 variable rules.sh. So we have given the execute permission to shell. Now it's time to run the script. So 2_1 and then variable. That's it. It's up and running on your screen, you can see the first module is allowed variable name pattern. I think all variables are allowed. See, these are the values of each variable. So each variable is allowed. We have seen that. And after that, we will see the second module. We are given the enough space to distinct to separate and create the distinction between the allowed and not allowed variable name pattern. So here you got the error. See, all we got all errors here. Here it is. Okay, even the substitution also we got the bad substitution because of this percentage, because of those symbols. We got the bad substitution. So and here this is the command itself is not found, and no job control command not found because it's the system cannot check this. So that's the reason. And here finally uh, the following variables are not protected. So here of course these variables are not protected, just to demonstrate that. Okay, just go through one more time before I close it. And the next topic that we are going to look into in this slide is command substitution. So one of the most useful features of shell script is the ability to extract information from the output of a command and assign it to a variable. So after you assign the output to a variable, you can use that value anywhere in your script. This comes in handy when processing data in your script. So there are two ways to assign the output of a command to a variable. First one is the backtick character that you can see on your screen, and the next thing is example testing, and this is how you have to give. Here this date is a command, so the output of the command is being substituted as the value of the testing variable. Testing is a variable name, and then the output of the date command has been substituted as a value for testing. Okay, so this is one way using the backtick, which is on leftmost part of your keypad, exactly on the button where you find a tilde symbol. Okay, then the second one is using dollar and parenthesis, dollar and open close parenthesis format. Here is one example as a similar. So here also we want to assign the output of date command to the testing variable is in a different format. Okay, so now the above command, this command substitution allows you to assign the output of a shell command to a variable. This is very useful as we go ahead into advanced shell scripts. So this is one example that you can see. For example, echo the date and time, or in spite of directly putting, you can directly use dollar testing. And what is the output you get? Testing output is a date. So the variable testing here receives the output from the date command and is used in the echo statement to display it. So running the shell script produces the following output. You can see that this is what you will get at the end of the execution of this command. The date and time are the output of the date, which is substituted to the testing variable. So that's what you get it. Okay. So now let's do one more exercise in command substitution. Okay. Let me, okay, clear the screen first. Yes. So we will vim it again. Vim it. But this time the name I want to give again starts with 2 underscore. This is second part of it. So 2, and then name is variable command substitution. That's what the name I want to give. So I will click enter, and I will press I to enter into insert mode, and this is our bin bash shebang bin bash. And after that, this is our first module. Here let's do the command substitution. Echo output of the date command to the test date variable. So here it is. Here we have used the backtick symbol. You can see that backtick symbol, and our variable name is test date, and then the output of date command should be substituted as a value for the test date. That's what we want. So uh, now assigning value to the variable is done. Now it's time to access that. So that's what. Now let us access the test date variable. So now we will use the test underscore date variable in a protective mode, and we'll get it. So that's what the script that we have written now. And that's first module. And for the second module, we will write echo, that's capture the current date and use it to create a unique file name in a script. Okay. Here we are going a little bit more advanced, but what we want to do is, today is fundamentally for us a variable name. Then after that we are using two commands here. One is date plus, and then year month d. So and a dollar anyway to dollar should be preceded with any command when you want to call that variable, call that command. Okay. So now let us access this variable and see. So the date and time of today's using, and then in a protective mode we put it in curly braces. So let me click escape and enter into extended mode, and then press W Q and press enter. So let me give the permission to the shell to execute it. That's O plus X and then 2 underscore 2 variable. Yes, we have given the permission. Now it's time to execute it and see what's gonna happen. 2 underscore 2. That's it. You got it. The response from the script is in front of your screen. You can see it. The date and time are ved 11 Jan, and then that's it. IST Indian Standard Time. It's 2023, and the time is 11:55:52. Okay, and on other side, here this is what we want, right? 23:01:11. This is the format which you want. In spite of this, we want in this format, so we have done it there, and here is the output of that that module that we have written in that script. Okay, just go through this output and then script once again. You just write the similar script. You just follow me while I'm writing the script, and execute it and enjoy it. Enjoy the output, because these are all fun. So before we explore further commands and script, further shell script, advanced scripts in Bash. Before we delve into those things, let us try to understand what all special characters that we have in Bash, and then what is the purpose of each special character. Let's begin with a pound symbol or hash symbol that many of you guys know. This is commonly used in Python also as a commenting uh, symbol. So even here also we used in our last two exercises for the same thing, to comment a section, then or to write a comment. And the second symbol for us is a dollar symbol. Dollar symbol indicates the name of a variable. So we have done it. If you just want to call a variable, variable's value, you have to attach or precede a dollar symbol with a variable name. So then only you can call variable's value using variable name. Then we have a backward slash. This is escape character to display next character literally, so that we will do it in our further exercises. Okay, then we have open and closed curly braces. So this one is used to enclose a name of a variable. In another way, we call it as protecting the variable. So protecting the variable. This also we have used in our previous exercise. Then we have a colon command separator. It's mainly a command separator, so it permits putting two or more commands. We have done this exercise in our previous module. We just go through that module once before you come here. Then we have a double colon. A double colon is also called as a terminator. A terminator, that's it. It's used as a terminator. It will terminate the uh, complete scripting shell there at that when you give that double semicolon. Then we have dot command. We also call it as the period, so it is equivalent to the source. Then we have dollar question mark. It's a exit status variable. And then double dollar, it's a process ID variable. Then we have open and close square brackets. So this is a test expression. Anyway, we are going to look into um, arithmetic operations in Bash scripting. So in that time, we will be widely using this open and closed square brackets. Double open and close square brackets. This is for test expression. It's more flexible than single open and close square bracket. On other side, if you precede open and close square bracket with a dollar symbol or a double parenthesis, this is mainly for the integer expressions or integer calculations or integer logics. So then we have a double vertical bar and double ampersand and exclamation mark. So double vertical bar is for logical R, and double ampersand is for and exclamation mark is for not logic. These are different logics that we use. So these are by and large the major special characters that we use in Bash shell. So now let us look into quotation marks. So how these quotation marks help us. So if you put a just quotation mark, what does it mean to the shell? So double quotation will begin with if you enclosed string, if enclosed string is expanded, in that case we use a double quotation. On other side, if you enclose any variable with the double quotation, it literally prints the variable name. That's it. It literally prints the variable name. If it is single quotation, even it prints the dollar. Then if it is back quotation, it's a back quotation. It's not the back tick mark, it's a back quotation. In this case, back quotation is basically used for command substitution that we have seen. It's also called as a back tick. Back tick. So back quotation or back tick is used for the command substitution. So enclosed string is executed as a command in this case. So example, echo backtick or back quotation and pwd prints the output of the pwd command. That's the print working directory, print present working directory. So in bash you can also use dollar and then parenthesis instead of using this other ones, instead of using pwd, that we have discussed in our previous slide itself. You just go through it once before you come to this slide. So next, after this we'll be looking into um, arithmetic operations in bash. Another feature crucial to any programming language is the ability to manipulate numbers. Unfortunately, for shell scripts, this process is a bit awkward. There are two different ways to perform mathematical operations in your shell script. The first one is the expression command or the expr command, just expr. Originally, the Borneo shell, that's the Borneo shell, that sh Borneo shell provided a special command that was used for processing mathematical equations. That is the expr command. Allowed the processing of equations from the command line, but it is extremely clunky. So then we have moved to the another kind of doing this operations, arithmetic operation, that we'll see. But let's clear the screen first. Okay, expr 1 plus 5, that's that. expr, this was the initial way of performing mathematical or arithmetic operation. 1 times 2, sorry, that's my bad. expr 8 minus 2, that's 6. Then expr 1 or 2, so the command itself is not found. Then expr 8 plus 8, it's 16. So this is how the initially the Borneo shell has used this command to do the arithmetic operations. But now, so but we can also do it using brackets. So if you want to use only expr command, then you have different different ways of doing different operations. So here in this case, the first uh, here 1 is an argument 1 and 2 is an argument 2. So if you use a vertical bar in between argument 1 and argument 2, then that returns argument 1 if neither argument is null or 0, otherwise it returns argument 2. Similarly, argument 1 and argument 2, this is again for the AND logic. So these are different logics, these are logical gates. And if you use a less than symbol, it's again another logic. Argument 1 less than argument 2 returns 1 if argument 1 is less than argument 2, otherwise it returns 0. And another logic is argument 1 less than or equals to argument 2, it returns 1, that's argument 1, if it returns 1 if argument 1 is less than or equals to argument 2, or else it returns 0. These are all different logics. If another condition, argument 1 equals to argument 2, if argument 1, that's 1 is equals to 5, is same, if one argument 1 and argument 2 are same, then it returns 1 or else it returns 0. And similarly happens with the argument 1 greater than or equals to argument 2. If that condition is valid, if that condition is it is complied with that condition, then it returns 1 or else it returns 0. And argument 1 greater than argument 2, same thing happens. Argument 1 plus argument 2, here it just returns with the arithmetic sum of argument 1 and argument 2. And whereas here argument 1 minus argument 2, it returns with the arithmetic difference of argument 1 and argument 2. Argument 1 asterisk argument 2 returns the arithmetic product of argument 1 and 2. And forward slash, if you use operator, then it returns the arithmetic coefficient. Then if you use a percentage symbol, it returns with the arithmetic remainder. If you use a string and then colon rejects p, it returns the pattern match if rejects p matches a pattern in the string. So few more operations, few more operations that we can do using this. Okay, so then we moved to the second another way of doing, that is using brackets. So the bash shell includes the expr command to stay compatible with the Borny shell. However, it also provides a much easier way of performing mathematical equations. That is, in bash, when assigning a mathematical value to a variable, you can enclose the mathematical equation itself using a dollar sign and square brackets. So that's what we have discussed in even in our previous slides. So you can enclose the mathematical equation using a dollar sign and then square brackets. This is how we do. So this mathematical or arithmetic operation has been assigned as a value to the variable 1. So now when I call echo variable 1, it will print the output of this arithmetic operation or that arithmetic expression. So using brackets makes shell maths much easier than with the expression command. The same technique also works in shell scripts also, but normally we follow this one only in spite of going with the rudimentary or primitive old expr command. Let's go to this and let's use a square bracket 1 plus 5. So the command itself is not found. So let's clear the screen and then where 1 equal to without no spaces and then dollar 1 plus 5. Sorry. Now let's echo var 1. Here is the answer. That's how you can use dollar square brackets preceded with the dollar to enclose the expression, enclose the arithmetic operations. Now let's look into a floating point solution. If it is a floating point arithmetic operation, how will you do it? You can use several solutions for overcoming the bash integer limitations. The most popular solution uses the built-in bash calculator called BC. Okay, that is one way. The basics of BC, that the bash calculator is actually a programming language that allows you to enter floating point expressions at a command line, and then it interprets the expressions and calculates them. It is one of the utility, one of the GNU utility that you can use to do the floating point calculation that are not possible with the normal operations of bash. Okay, so and basically it returns the result of the calculation that we have mentioned. That is one way you can invoke the BC utility. That's called a bash calculator. It's BC, it's a bash calculator. Or else the another way of doing it is the same way. Here it is. So now the basics of BC, we'll just go through it once. So it consists of uh, numbers, both integer and floating point. It can take any one, either integer or floating point, and variables. It takes simple variables and arrays as well as, and you can if you want to attach a comment, and this is how you have to use a forward slash and then asterisk, space, asterisk, and forward slash pair. Then expressions can be included, and then programming statements such as if and then statements can also include, and functions can also include. So basically this BC, that bash calculator utility, can do a lot of activities for us. So now let's do one exercise in arithmetic operations. So let's get into the our shell script. So let's clear the screen first, and then let's vim it. Vim 30 and arithmetic operations.sh, and then I into insert mode. As usual, we have written the shebang and bin bash, the shell. Then our first module, let us experiment some of the arithmetic operations. That is our first module. In that we want to experiment the expr command, that expr command. So this is the command expr, and these are the argument one. First argument one is 1, and then we use summation operator, that is plus, and then argument 2. And let's see, we use the expr method to summation to do the summation of 1 and 5, and let's see what could be the output. That is our first module. Then we will go for the second module. In the second module, uh, here we use expr method to do the mathematical operations, but here we have assigned values to the variable 1 and variable 2, and we want to do that expression calculations using a variable. Now variable 3 itself, we are attaching an expr command, and then we are dividing the variable 2 with the variable 1, and we want to print that result as a variable 3. Let's see what's going to happen in the same way. Then echo, and then final module is using brackets, and the next module is using brackets. So here, in spite of using that primitive expr method, so this time we are doing using brackets. So variable 4, and the value that has been assigned to variable 4 is the output of expression summation of 1 and 5. That's the output, and we just want to print the variable 4 after that. Similarly, we have added a little bit complex calculation. Variable 5 is 100, variable 6 is 50, variable 7 is 45, and we just want to do a complex calculation. That's a multiplication of variable 5 with the subtraction or difference of variable 2 and variable 1. That is just a minute, variable 2 and variable 1 has values on top. Let's see. Okay, this is the complex calculation, and finally we are going to use the bash calculator. It's a BC command or bash calculator. that module is the last one. So using the BC, so what we have to do is this is how you can call it. We have commented all those things. So variable 10 and echo and scale for 3.44, and after that you pipe it and then you call the BC. BC is to do all this operation, whatever I have mentioned till here, all these operations in BC. That is our bash calculator. And that's what, this is the way we do using bash calculator. Whatever operation you want to do, you mention that operation and then you pipe it with the BC. The BC is our bash calculator. So all commands has been inserted into our file or our script. So now let us go to the extended edit mode and then type WQ and enter, and let's give permission to the shell to execute it, and once that is done, then we will execute the file and see. So execution permissions are given to the shell. So now let's call and let's execute. That's it. I think almost all are done. No problem, no errors, everything is done. The xpr command, the calculation, and we got the 6. And then after the xpr command, xpr method, we used a bracket method. So we have taken 2 variables and that also done. Then after that, using bracket method, we have done a complex calculation, that is also done. Then finally we used bash calculator using bash script. So it has given even the complex calculation is also executed. See, you got the floating point number. That's what the problem. This is where we were unable to do the floating point calculation or integer calculation with the expr or brackets, using brackets. But now using bash calculator or BC, we are able to do the floating point calculation also. Just go through this script one more time and execute it and experiment it and enjoy it. Many programs require some sort of logic flow control between the commands in the script. There is a whole command class that allows the script to skip over executed commands based on test condition. So these commands are generally referred to as structured commands. Structured commands. So let's start working with these kind of structured commands. One of the most basic type of structured command is the if then statement. You can clearly see on the screen the if then statement will have the following format. It begins with if keyword, then a command, and after that we'll write then, and after that we will take indentation and we'll give some more commands. Then finally we will close this statement, if then statement, with fi. So let's take a simple example to demonstrate this concept. For example, we'll write if, we'll take the following example and write let's write this file and execute it. Okay, vim, we will name it as test1.shi. So let's add shebang first, then bin bash, then come down a bit more. So let's give comment. So it's to demonstrate the if then statement. Then let's give if, and command is pwd. Then after that, then if it works, then what you want to do, echo it worked, then get back and close the statement. So wq, so give the permission to execute it first, w and then test1.sh. So execution permissions were given to the shell, and let's see what's going to happen. So now if you execute this script now, but before that, what this script consists of, this script uses the pwd, that's a present working directory command on the if line. If the command completes successfully with a right exit status code, then the echo statement should display the text string. When you run this script from the command line, you get the following result. We should get it. Let's see what's going to happen. So it will show you the uh, directory, present working directory, and then it will also print the string that we have mentioned in the then section. Okay, let's get into the WSL and execute the script. It's test1.sh. Here it is. This is our directory. That's a present working directory, and here the one which is mentioned in the then section. So it has worked successfully. Now the shell executed the pw command listed in the if line because the exit status was 0. If the exit status code was something else, then it might not have done the same thing. So here the exit status code was 0, so that's the reason the pwd was printed, and then it also executed the echo statement that is listed in the then section. So now let us try with the different exit status code in if line or if section, and we'll see what's going to happen. So the following code that we are going to write, so we will name it as vim test2.sh, and sorry, I'll put shebang first, bin bash, and then space, and commenting this is to demonstrate if then with the uh, exit status code, and then we will write the code. If lam no to command something else, whatever, it doesn't matter, then echo it worked, then close the statement, and chmod wo plus x and test2.sh, and let's execute and see what's gonna happen. Test2 dot sorry test2.sh. Here it is. What it is saying, lam no to command not found. That's it. That's where it ended. So echo, okay, we'll add one more statement. We are outside the if statement, because if whatever command that you mentioned, it comes up with if it comes up with the other than 0 exit status code, there are three other exit status code. If it is not 0 exit status code, then it won't enter into that statement itself, it will directly come out. So that's the reason we'll do small modification in vim, and then we will add the final statement, that's echo we are outside of the if statement, and let's close it and execute it one more time. Here it is, the command not found, and we are outside of the if statement. So this is how your if then statement works. So then we will do one more exercise. which is related, a simple exercise which is related to if then statement. Then we'll write a file, a name called vim 4 hyphen 4_0 if-then.sh. So this is our file. First shebang, bin bash is done. Then our first module is testing the if statement. If then it worked, same thing, we have put it into this. And in addition to that, one more module that I have added is here. Okay, so read and parental enter number and num. So this is another, in spite of the simple command that we have put it in if section, here I have put an expression altogether. Okay, so it will take an input, we have to enter a number, then the expression compares whether it is greater than 100 or not. If it is, then it's going to execute others, whatever statements which are there in then section, or else it will simply get out of the statement. Let's see. WQ, and let me give the chmod for this file that we have just created, and then the file name is 4-0, and then if then. So we gave the permission. Let's execute and see what's going to happen. 4_0. Sorry. Yes, here it is. So let me make it bigger. If then statement, it has worked. If then statement, there was an error, then it directly came out of the if statement. The next if statement that we have used is, we have to enter a number. First we will enter the number which is lesser than 100, and we'll see what's going to happen. I will enter 45, which is lesser than 100. So script execution completed successfully. So it did not enter inside that, it just came out. So now what we'll do is, we'll enter more than 100, 125. So we have entered inside the if block. That's what I just want to say. That's it. You will enter inside the if block, and then whatever commands that you have mentioned in the then section all got executed. So, and finally the script execution is completed. The script execution completed was outside the if then statement. So that's how you can prove it. If the first if section exit status code is 0, then it's going to execute all the commands which are mentioned in the then section. If the exit status code of the if command, the command which is inside the if is not 0, then it's not going to execute the commands which are mentioned inside the then section. So let me execute one more time just to have some fun, nothing else. Okay, so here it's asking a number. This time I'll give 76. Let's see what's going to happen. Oh, it directly came out of the if then statement. Okay, again we'll execute. This time I'll say 245 and see what's going to happen. So we have entered inside the if block, you see here. Then it has printed date and it has printed something else. And then let's do a little modification in the same file, vim, and I want to add additionally with data, with with date, I want to add uptime as well as, and who am I. Okay, let's see what's gonna happen now. So that's it, and I'll press 250. We have entered inside the if block. Now one by one the commands which I have mentioned inside the then inside the then section all got executed. Date, uptime, and who am I? I'm the root user. Everything. I hope it's clear for you. So now we'll explore the if then else statement altogether. till now we have seen only if then statement. Now we will also see if then in addition with else. Okay, so in the if then statement you have only one option for whether a command is successful. If the command returns a non-zero exit status code, the bash shell starts move on to the next command in the script. In this situation, it would be a nice to be able to execute an alternate set of commands. That's exactly what the if then else statement is for. So then the if then else statement provides another group of commands in the statement. So let's go through it. It looks like the following way that you are able to see on the screen. If and then command, then after that the then section starts. In then section you can mention few commands, and after that you go to the else section. In else section also you can mention one or two commands, and then finally you close the if then else statement with fi. So what happens here, when the command in the if statement, here it is in the if statement line in this section, returns with a zero exit status code. Zero exit status code. The commands which are listed in the then section, that is here in the then section, are executed just as in a normal if then statement. What happens if you get a non-zero exit status code? That's my question. That is going to be handled by else. When the command in the if section, this part returns a non-zero exit status code, then the bash shell executes the commands in the else section, and then it will get out of the if then else statement. I hope it's pretty clear for you. So what will we do is uh, uh, we will do one exercise in if then else statement before we jump into the uh, elif. Okay, let me clear the screen first. If you want, I will make it smaller, and I will put it on left side of it. Okay, we will vim it now. We'll write a vim. Okay, now let me clear the screen again. Okay, just quit it. Oh, that's the reason. Okay, now yeah, vim, and then the name of the file that I'm going to write is 4_1, and it is if then else. If then else dot sh. Yes, so let me completely go up. This is our shebang, and here is the bash shell that we have mentioned, where the following commands to be executed. And here is our first module. So what's the first module? Testing the if then else statement all together. So first, if then else statement, test user is the variable, and the value for the test user variable is no such user. Then this is our if statement, if then else statement. Okay, if is our keyword. Then after that we used grep, a command. Grep is a command, and after that we attached a variable, that's a test user variable, and then we just want to check that variable is, it's a pattern basically, test whether we have it in a etc passwd file or not. I think I have explained maybe 50 times 60 times about the passwd file, because it's very much important for a system administrator. So that's the reason I have explained this file more than 50 times in my previous modules. So kindly go and watch those modules and come back here. Okay, so then the then section starts here. In this we have write echo the bash files for the user test user are this, and then finally lsa hyphen, again one more echo, and else section starts from here. In else section what we have written is echo the user test user is the variable does not exist on the system. Let's see what's going to happen. If we have this user test user, it's going to print whatever we are expecting in then section, or else it will directly come to else statement and it will say that there is no such user in past wd file. Then we are closing it. This is our first exercise. Let's execute the first exercise and we'll see, and after that we will move into the second exercise. Okay, so let's give uh, permissions to the shell to execute this file first. So chmod o plus x, and we'll have 4 underscore 1. Okay, so we have given the permission. Let's execute and see what's going to happen. Sorry, yeah. So if then forget about the other one. So here we have to enter, that's a second module. I'm not talking about that module at this moment. So here first we just want to check the if then else statement. So anyway, past wd this system anyway does not have a user name as no such user. So no such user, with that username nobody is there. So that's the reason it did not go to then statement, then section. It directly came to else, and then whatever that we have mentioned in else has been printed. So the user, no such user does not exist on this system. Okay, so now we will do vim again of the same file, and let's do a small modification in this. Here it is. Let's add a run and let's close it. Let's see, let's execute the file again one more time. Yes, it is. I'll make it bigger. You enjoy the fun of scripting with me. Yep, we have two users. Surya Charanteja is one user, Charan is another user, and whatever we have asked, the command that we have mentioned in then section has been printed, else has been completely neglected, completely avoided. You see, his home Charan, that's his home directory for Charan, that's been given here. Okay, so that's how you use if then else statement. Okay, sorry. Now let me clear the screen, and then again I'll do vim. I'll vim the file. Then let's understand the second module of the same. So in second module what we have done, so we have to enter a number. It's asking for an input. For that we use a read, basically read command. That's fine. Now if we gave a arithmetic expression or logical expression, if the number that we provide, that we give, if it is greater than 100, then of course it's, if it is correct, then it will give you 0 exit status code. Then we will enter into the then section. Then whatever commands that we have given in then section will be executed. And then if not that case, if the exit status code of if statement is not a 0, then it will directly go to the else, and then it will execute the commands which we have mentioned in the else. Let's see what's going to happen. So let me execute the file. Okay, I'll give 45. If 45 means it's not lesser than 100, 45 is lesser than 100, it's not greater than 100. So because of that, the exit status code is not 0, so it should not go into the then section. It should directly go to the else, and it has to print, and then it should get out of the if then else statement. Let's see what's going to happen. Yes, that's what happened. At 45, you have entered the number which is less than 100. This is what we have mentioned in the else. Then finally it got out of the if then else statement, and whatever you have mentioned outside of the if then else statement has been printed. That's the script execution completed successfully. So we'll execute the file again one more time, but this time with the number which is greater than 100. That's 150. Let's see what's going to happen. So we have entered in a if block. Now whatever that we have mentioned inside the if block has been a then block. The then section has been executed. So your number is greater than 100, and then we have mentioned date there, so we can see the date. And then else has been neglected completely because we got the zero exit status code in if statement, in if section. Okay, so now we will move on to nesting ifs. Instead of having to write separate if then statements, you can use an alternative version of the else section. That's called elif. So the elif continues an else section with another if then statement. So let's look into the syntax of the elif. So if, and then as usual command will come, then after the then section, and then elif, again commands, then if you use a elif, you can put an another then section. That's the, and you can add more commands, and finally you can close this whole statement with fi, okay, fi. So the elif statement line provides another command to evaluate, similar to the original if statement line. So it's like adding one more if then statement to the if then statement. So here, this is your first part of if then statement. If you add a elif here, so you can add one more condition, one more if kind of condition. Of course it is elif, but still it's a if condition. Then again one more then section to execute. If this happens, you execute the things which are there here, or else if this the second condition happens, then execute the execute the commands which are there in this then section. That's what fundamentally this if then else statement do. So if the exit status code from the elif command is 0, then the bash executes the commands in the second then statement section also. So now what will we do is we will go for one more exercise on nesting ifs, or we can call it as if then elif statement. Okay, yeah, we will get back to the WSL. Let me clear the screen and then vim it again. Vim, this time it's 4_2 if then elif.sh. So let me go up, shebang, bin bash, first activity is done. Then the first module in this is testing the if then else statement. Of course that's done, and then if then else, this is also if then else. Okay, yep, let me close this. Vim 4 3, this is comparison operator. That's fine. Vim if cd vim if then elif.sh. Okay, bin bash if we'll take we'll give the command directly pwd, then execute ls or execute who am I, then elif, one more command. Here we will give one more command which is not there, so I'll give a wrong command, that's gone. Then again one more, then here I'll add who, then finally fi. Let's see how it works. Chmod o plus x, if-then-elif, then if-then-elif dot sh. That's it. pwd, you got the exit status code as 0. So then in then section that we have mentioned in first one, first then section, that's who am I, that got the root user. Whereas in second if statement, because this is nesting ifs now, in second if the command that we have mentioned as given a non-zero exit status code, that is the reason it was completely avoided. It was completely avoided. So let's do a little modification. So in this I will add one more command. I'll add okay, pwd is added on top, ls I'll add, and let's close it and wq. Let's okay, anyway, the first one is done. Yep, here it is. So the first one, that's how it works, a nesting ifs or if-then-elif. Here the first line, the first if statement is not working. It has thrown a non-zero exit status code, so there is no command such. So that's the reason the then was neglected completely. Then it moved to elif, then it has moved to elif statement, and then it had executed the commands that were mentioned within the then statement also. However, if the first if statement, if that throws a not zero exit status code, then it is not going to execute the second if statement or elif statement. That's how it works. So if you just want to uh, experiment more, so here I'll put correct statement, correct command, and let's see what's going to happen. Here it is. Only the first one has been executed and the second one has been neglected. So that's how it skipped the second elif, or elif, the second section, the elif section has been neglected. This is how the nesting if or elif works. So the last category of the test comparisons is quite possibly the most powerful and most used comparisons in shell scripting. So this category allows you to test the status of files and directories on the Linux system. First we will start with string comparisons. In string comparisons, so basically we have different conditions. All these conditions give you the ability to check file system files within shell scripts. They are often used in scripts that access files. Okay, So if you look into this, so the first comparison is, before we have seen arithmetic comparison, the logics to compare between argument 1 and 2, but here these are string comparisons. In first comparison, string 1 equal to string 2, it checks if string 1 and string 2 are same, all characters are same, then um, it checks that, then the output would be, if they're same the output would be 1, if they're not same the output would be 0. So same thing will be applicable with all other not equal to condition, and less than condition, greater than condition, and then we have 0 condition. Check, for example, hyphen z string 1 checks if string 1 has a length of 0 or not, and if hyphen n string 1, in this case if that is the condition, checks if string 1 or str1 has a length greater than 0 or not. So these are different comparison operators that we use to compare the two different strings or same strings. So the equal and not equal conditions are fairly self-explanatory with strings. So it's pretty easy to know when two string values are the same or not. So then what will we do is, we'll take some example, and then we will uh, do one exercise before we move on to the file comparisons. So let's open, and let me clear this screen, and then let's vim it. It's 4_3 comparison files. Okay, cd scripting ls clear, and after that vim it 4_3 comparison operators dot sh. Hi, let's begin with shebang and bin bash, and after that we'll write our first module. In our first module, the activity is to test the numeric comparison. First one is numeric comparison. This we have done it earlier, but let's do it. So we have taken two variables, value 1, variable 1 is value 1 and value is 10, value 2 it's 11. Now our first condition in if section is, if value 1 greater than 5, then do this, or else another if statement, if value 1 equal to value 2, then do this, or else do this. So this is one condition. So that anyway numeric one, we have done it earlier also. So here one more, that is also numeric. So the second module of, let me check, okay, value 3. So for the second module, let me put one more echo, one more echo, one more echo. Yep. So this is our second module. Even here also same logic we have applied. Then the string comparison operator is what we want to stress upon at this moment. So here we have echo, that's the decoration, first two echoes, then string comparison for that. So what we have done is, test user is the variable that we have taken, and we have attached a value to that. Then now we just want to compare. So we have used user here, user and environment variable. So that user, of course I'm a root user here, so in this case user is, if it is equal to the test user variable, then automatically the commands that are presented inside the then section will be then section will be executed, and then finally it will come out of that. So first we will check this one, specifically this module, and then we will and then we'll get back to this file, and then we'll check other modules as well as. So let me save and quit it, then chmod and o plus x and 4_3 comparisons. Oh, permissions are given. So now let's execute it and see. That's it. So first one is numeric comparison, that we are not bothered much at this moment. Then we have float comparison using floats. That is also fine for us. What is important at this moment is string comparison. So that is here. String comparison, just a minute. Yep. String comparison. So directly, this is not a bad user. This is not whatever that we have mentioned in the else has come up after comparison. So now what will we do is we'll clear this one, and then we'll vim it again. Vim. So here the problem here is test user and then actual user are not same. Okay, that's why what we'll do is we'll add a user, and then I will change this test user to root, value of the test user variable to root, and let's see what is going to happen. Here it is. That's okay. Welcome root. that's what I want to say. Let's again get back to the file, and I'll try to explain more in depth. Okay, so now user, that's environment variable. If this is not equals to this, then this should be printed. But if it is same, whatever that is mentioned in the else should be printed. So that's what had happened now. So now user and test user is root, and user is also root. They are same. So that means we will get a non-zero exit status code. So then this if then it will directly enter into the else section, and then it will print welcome the test user. Okay, so that's what had happened here. I will execute. So welcome root. Okay, so now we will look into a final module of string comparisons. So variable 1 is baseball, variable 2 is hockey. Now there is a comparison between variable 1 and variable 2. Then if val1 is greater than val2, if the exit status code is 0, then whatever commands that are mentioned in then section will be printed, or else it will be printed, the commands that are in else will be printed. Let's see what is going to happen. Baseball is greater than hockey. So val is greater than val2. So this is absolutely, so whatever that had happened in val1, actually it got in if section, we got the exit status code as 0. So whatever that is mentioned in the then has been printed. So now what will we do is we'll just interchange the variables. So here we'll put hockey, and then here we'll put baseball, and we'll see the magic, what's gonna happen. Yes, let's. Now hockey is greater than baseball. Okay, this is the misuse I was talking about. This is the misuse I was just talking about. Okay, so now we will look into the file comparisons. Till now we have seen the string comparisons. Now we will look into file comparisons. So in file comparisons, if you can use -d, just -d to check if file exists and is a directory. If it is -e, it will check if file exists or not. And if it is f, it will check if file exists as well as it is a file or not, because everything in Linux is a file. So that is the reason. If you just give -d option, so then it only checks whether it is a file, and after that if whether a file exists based on that name or not, and also it also cross checks whether it is a directory or not. Similarly for capital G, it checks if file exists, and the default group is default group is the same as the current user. Similarly WX, if the checks if file exists and it is executable or not. And -w, it checks if the file exists and is writable or not. And -s, it checks if file exists and is not empty. And similarly we have file1, -nt, file2 checks if file1 is newer than file2 or not. So these file comparisons are heavily and very much useful for a system administrators when he's handling with a lot of files. These are very important, just focus on this. Okay, and file1 -ot, file2 checks if file1 is older than file2 or not. So these file comparisons are very beneficial. So these conditions give you the ability to check the file system files within shell scripts. So they are often used in scripts that access files. So now what will we do is, before we move on to the another section, so we will go to our WSL and let's do one more exercise. Let me clear it off, and then Vim for file comparison, that's what we are going to do. So let's. Okay, yep. So first, as usual, shebang bin bash is done. Now testing the file comparison. This is our first module in this echo checking directory. So let's take one variable, that is a jump directory. That is our variable name, and then we have given a directory, a sample directory. That is home directory of Charan user. Then we have a first if condition, that is -d. It asks -d will check whether it is a file or if whether that file exists or not, and then it also check whether it is a directory or not. If it is a directory, then we'll get the exit status code as 0. Then whatever conditions that are mentioned inside this then section will be executed, or else whatever commands that are mentioned in the else section will be executed. Let's see what is going to happen. But okay, but before that let me give permission for others to execute this file. Yeah, just a minute. Okay, here it is. So checking directories, yes it is. the home / Charan directory exists. As it exists, then whatever commands that are mentioned within that has been, that's what in then statement, this is what is mentioned, that this one has been executed. If you have doubt, I can show you that. Okay, so let me go to the cd. Of course, I don't need to go lsl and then lsl of home. Here it is. Charan. It's a directory. Okay. So next we'll put test and we'll see what's going to happen. In spite of that, we'll put test. Let's see what's going to happen. So let me go up, scroll up a bit. Yes, checking directories. The test directory also exists. So let's change it to Divya and let's see what's gonna happen this time. Check home directory. I'll scroll it down a bit. Yep, just a minute. Here it is. I think. Okay. Let me execute that one more time. Yeah. So, yep, here it is. So checking directory, the home or Divya, home and then Divya directory does not exist because it does not exist. So whatever that is mentioned in the else has been printed. If you have a doubt, I will show it again. It is not an issue. L and then / home. Here it is. You have Charan, Surya Charan Tej, test. That's it. No Divya in this. So that's how it works. Then we will move on to another module. That module is done. Now this time checking for a file again. This time the variable name is item type, item name, and then we have taken home as our environment variable. The output of the home environment variable is assigned as a value to the item name. Then this is our first condition. Here we are using option E. So option E means what? It just checks the file if exists or not. That's it. Nothing else it will do. If such file exists with this name, then it will do the item and then item name does exist. The item name does exist, but is it a file? We are not sure. For that, we have written a nested if loop inside that. Okay. For that, we have taken F option. So F option means it checks if file exists with that name and also it checks whether it is a file or not. And so it checks that if it is a file and if it file exists, then it will print the commands that are mentioned in the then section, or else it will just print which are mentioned in else, and finally it will close it and it will come out of the nested if and final else at higher level else is this. Okay, so let's check this one first and then we'll come back. The second module testing is going on now. Let's see what's going to happen. Yes, first one is done. Now checking for a file. The second one, the item being checked, that is a root. The home address, for because I'm a root user in this, so root user's home address is obviously a root directory, so that's correct. Then we are checking whether it is a file or not? So it's a directory, the item, but is it a file? That's the next question. The root does exist, that we have been proven. Then is it a file? That's the question. After that we are entering into nested if loop. No, root is not a file, it is a directory. That's what it is saying. I'm checking for the read access. Okay, you got it. This is how these if loops are helpful in automating the system administration process. Okay, so now let's go to the file again and then come down a bit, the third module. So once that is done, now we are entering into the third module. Here testing if you can read a file or not using these techniques. So pw file is our variable. So what is the file name that we have attached? Shadow is the file name that we have attached to the pw file. Now we will call a file, and we'll take another variable, file name, and then home address and sentinel. Okay, I do not know whether a sentinel this directory exists or not, but let's check. And first thing, f will check, is it a does a really file exist with such name? If exist, is it a file or not? That's what it's gonna do. Okay, so now after that, if it is a file, then automatically here we have given a nested if loop with s. So s, it checks if file exists and is not empty. Okay, so and then else. Okay, let's get back to the, just a minute. Yep, yeah, we'll check it. We'll execute it one more time and we'll check. Yep, so checking for the read access, and we got all the information. That's shadow file. So Charan, and then encrypted password for the Charan and everything. And finally checking for the empty files. Yes, that is done. And after that, the last module, in that we gave the root sentinel. This kind of directory does not exist, so that's the reason this at the initial level itself, we came out of the statement. So let's move into the more complex and complicated and very helpful components of Bash shell scripting. And these components will help us a lot in automating the tasks and activities in Linux system. So that is our looping with the first statement. We'll begin with the first statement. Iterating through a series of commands is a common programming practice. Often, you need to repeat a set of commands until a specific condition has been met, such as processing all the files in a directory. Just one example, we have plenty of example. And second example, you can check all the users processing all the users on a system, or all the lines in a text file. So the bash shell provides the for command to allow you to create a loop that iterates through a series of values. So each iteration performs a defined set of commands. So using one of the values in the series. So here is the basic format that you can see on top of my screen. Here is the basic format of the bash shell for command. Here it is. So for, and then you'll have a variable. If you know Python language, it's quite similar to the Python for loop. You'll have for keyword, and then iterative variable, and then in keyword, and then finally you have a list or a series of uh, or values that the for loop will iterate through. Okay, a loop that iterates through a series of values. Those are that list here we have mentioned. And then whatever activities you want to do with each iteration, those you have to attach in do commands, and then finally you type done to close the loop. Okay, so that's how a for loop works. So uh, you supply the series of values used in the iterations in the list parameter. Here list parameter, you can specify the values in the list in several ways. So what happens in each iteration, it depends upon the number of iterations is equal to number of items which are present in the list. Okay, so in each iteration the variable, the var contains the current value in the list. So the first iteration uses the first item in the list, the second iteration uses the second item in the list, and so on until all the items in the list have been used. And the commands entered between the do, here it is, between the do and the done statements, between do and the done statements can be one or more standard bash shell commands within the commands. So the variable contains the current, and then so here in the first line the variable contains the current list item value for the iteration. So let's take one example as an exercise and we'll see how this works. So let me clear the screen first. Yes, it is done. Vimit, and the name of the file I want to give is 5 for loop, that for.sh. Yes, it's a simple one. First shebang and bin bash, the shell has been mentioned. And after that, our first module, the comment is to test the for statement, again the decoration, and after that we have for keyword. Then after that, this is an iterative variable. This is the variable which enters in the list and iterates through the list. And then in keyword, and after that we have a list of items: Alabama, Alaska, Arizona, Arkansas, California, Colorado. So this is the list. And then for each iteration, it has to execute the following command. That's the next state is test. Okay, and test is this is our variable, the iterative variable. So for each iteration it will at fetch a certain item from that list. For the first iteration it will fetch Alabama. For the second iteration it will fetch Alaska. This test variable, it's iterative variable, that will fetch Alaska. For the third iteration, test will fetch Arizona. For fourth iteration, the test will fetch Arkansas, like that. And whatever command that we add in between do and done will be executed for each iteration. So let's uh, get out of the vim and then give permissions for the shell and execute the file and see what is going to happen. Chmod, correct, yes or no, and then o+x, then file name. Permission has been given. Let's execute the file and see how it's going to work. Here it is. So how many are there? 6. The list consists of 6 items, and the 6 for 6 iteration we got the 6 responses from that. This is how a for loop works. The next state is Alabama, the next state is Alaska, the next state is Arizona. So this is how a for loop works in Linux Bash shell scripting. So then we will move on to reading values in a list. The most basic use of the for command is to iterate through a list of values defined within the for command itself. For example, if you take the following example that we have used just now, so now each time I just want to give a more explanation for that. Each time the for command iterates through the list of values provided. Those are Alabama, Alaska, Arizona, Arkansas, California, Colorado. It assigns the test variable in the next value in the list. The test variable can be used just like any other script variable within the command statement. So after the last iteration, the test variable, once the last iteration is done, that's the last iteration is Colorado. Once the last iteration is done, the test variable remains valid throughout the remainder of the shell script. It retains the iteration value unless you change its value. So before we move on to reading complex values in a list, so let's do few more exercises so that we'll get a fantastic hold on the for command, because this is very useful in automating the activities in Linux. So Vimit, this time first exercise, another exercise for and okay, so the first activity remains same. That's done. In addition to that, what we have added is echo the last state. What happens? I just want to focus on what happens once the test, that iterative variable, finish the last iteration. What happens that? So that's why echo the last state we visited was this. So once that is done, we'll come out of the for loop. So then test Connecticut. So echo wait, now we are visiting. So we just want to do this again. Let's execute chmod permission. Let me change one here, and then that's it. So the same result, but the last state we visited was Colorado. So now we are visiting Connecticut. So I just want to demonstrate that once your list of iterations are done, you will come out of the for loop, and then whatever command that you mention after that can be executed. So that's what we have proven it here. So then we will write one more file, that's 2 for.sh, and this is a simple example. So as usual, bin bash, it begins with the bin bash, and this example of how to properly define the values. So again, here there are different ways of adding a list of values. So till now what we have done is, without using any quotation marks or anything, we just mentioned one by one, like an argument in Linux. So here what will we do is, we will use double quotation marks and see how it basically responds. Okay, so for as usual, and then we have variable, and then in keyword, then after that a list of values. So list of values, so Nevada, New Hampshire. So basically this is one word, New Hampshire is one word, but as we haven't used a double quotation here, so it's okay, I'll add yeah. So double quotation, now it's a New Hampshire is a single word, New Mexico is a single word, New York is a single word. So if you don't use a double quotation, for example, let me remove the double quotation, and then I also remove the double quotation here. So now let's see what is going to happen, and we'll see, then we will add a double quotation and we'll see the difference. Okay, so let's get back, and then chmod, this time it's 2. Let's execute this and see what is going to happen. Yep, this is what is happened. So Nevada is one, New is one. There is no city as New. Okay, New Hampshire is there, but no New and then Hampshire. So that is the problem. So what will we do is we'll add a double quotation so that we can give even the spaces to write if any city which consists of a two words and there needs to be a space in between these two words, then how can we do that? Because if there is a space in Linux, it's considered as a separate argument. So for that reason, it's better to include double quotation. So I'll add a double quotation here as well as here, and now let's see how that works. Here it is. Now going to Nevada, New Hampshire, New Mexico, New York. That's it. So that's what I want to show here. So then now let's move on to reading complex values in a list. The for command separates each value in the list with a space. If there are spaces in the individual data values, you must accommodate them. So using double quotation marks. That's what we have done it. And then so adding this double quotation marks, we are able to keep that spaces also in between. So now so let's look into reading a list from a variable. So often what happens in a shell script is that you accumulate a list of values in a list of values stored in a variable, and then need to iterate through the list. So you can do this using the for command as well as. So what will we do is, in spite of directly giving a list of items, what will we do is we will allocate, we'll store all these list of items to a variable, and then we will use this variable in for loop, and let's see how it works. Okay, this is that list, same Alabama, Alaska, Arizona, and we have attached as a values to the list, and then we'll use that list in for loop, and then we attach it. Okay, so let's go to the exercise and we'll do directly there, and then we'll return back here. So vim 5, it's 4, yep, file, it states okay. Okay, so here is what we have the file. Let me go through the file one so that it would be clear. So it's reading the complex values in a list. So how would it work? So for test and in, so test is our variable, in is keyword, and from here actually starts the various complex values. I don't know if this will work or not. let's see what's going to happen. So this is what we want to print, and let's see. Let's get back and let's execute. Let's give chmod, and then okay, o plus x and 5 3, and yeah, here it is. So word I don't know if this shall work, like it has divided the complete sentence into three words, three parts. One is, the first one is I, second one is don't know if this will, and work. So why that had happened? Because of so the one which is in between the single quotation mark is considered as one work. So I, and then done, and whatever is in between, this is considered as one. So and work. So that's the reason it had happened. So to add a complex values, it's better to use a double quotation mark or single quotation mark, or just put it inside that. Okay, so similarly, another example, I don't know this will happen or not. So in spite of that, simply you take the double quotation mark I don't know, and you take double quotation mark and use it. So that's the one. So next, okay, we'll look into another example and another exercise, that is vim 5 for reading com. Yeah, this is what we are looking for. So bin bash it starts, then file. Here the states is mentioned, out of which for state and in cat file is the example. So concatenate this file. So we have mentioned, we have written the states file, uh, it is in that directory. Then after that, after concatenation, each word will be used as a state to this. Let's see. Okay, yep. So chmod o plus x and 5 4, and then 5 4. So cat states no such file or directory. So vim states, yes, it is there. What's wrong? To the variable file uh, uh, in double quotation. So basically the value should not be enclosed in double quotation, because this is file, right? So I will remove the double quotation, and let's see. Okay, so now the value, the output of the states file is attached as a value to the file variable, and then after that we use a for loop state, and in that we have used list the cat command, and then cat command will concatenate all the items that are present in the states file. Then after that it will echo for each iteration visit beautiful, that state name. Okay, so let's see. We have changed it, and we will commit the changes, and then we will save it and then quit it. So let's execute and see what's going to happen. So here it is, absolutely working fine. So visit beautiful Alabama, visit beautiful Alaska, visit beautiful Arizona, beautiful Arkansas, Colorado, Connecticut, Delaware, Florida, Georgia. So this is how you can uh, read a list of items from a file which is located in a different directory, or maybe in the same directory. So if you want to check what is that, if you want to concatenate the file name, what is the file name? I forgot. States. Yes, here it is. See, the first iteration Alabama, the second iteration Alaska, the third iteration, that's okay, Arizona. There will be slight this thing, Arkansas, Colorado, Connecticut, Florida, Georgia. So almost everything has been covered. So this is how you basically read values from command or from the file. So the same example we have given. So this is the another way to generate values for using the list, is to use the output of a command. So use the command substitution technique to execute any command that produces output, and then use that output of the command in for the another command. So that's what the example we have seen just now. So next we will move on to reading a directory using wildcards. Reading a directory using a wildcard. So reading a finally you can use the for command automatically iterate through a directory or files. So to do this, you must use a wildcard character in the file for file or path name. So this forces the shell to use the file globing. File globing is the process of producing file names or path names that match a specified wildcard character. So if you want to see the example, so for file in this directory, so whatever files that are there in that directory, all for, and then this is the file is a iterative variable, in is a keyword, and then this is the directory where we have all the files. Then do this. Then if it is going to check whether there is a file or not, and then it will confirm whether it is a file type or not. That's what. If it is, then if it is a file, then if it is not that, if as it is a D, so it will confirm whether it is a directory or not. Sorry, that's my mistake. My mistake. As here the command that we have mentioned is D option. D option, it will confirm whether it is directory or not. If it is a directory, then it will print file whatever that we have seen is a directory. So then if it is not, it will say it's a file. Okay, so that's what the script that we have written. Let's get back to the WSL and see. Let me clear this. Vim 5 6 for read var. Okay. Yep. ls. Now let's write that. Before that, we'll create some files. We'll take what is it, where have we now pwd. So there are a lot of files in it, in the tmp scripts. That's more than enough for us. Then after that, okay, we will add one mkdir. Okay, that's fine, that's fine. This we can take up. So let's create vim and for wildcard dot sh. Yes, shebang. Insert mode, then go for shebang, then bin bash, and then let's begin. So for loop for file in tmp, and I forgot that, sorry. tmp, let me get back. pwd, okay, scripts. Scripts, then all. So do if statement will start here, then I will check for directory first, and then what's that variable name I have used, dollar file. Then let me close it. Then I will use, sorry, let me get back to that indentation. Then an echo if it is a directory, then use the variable file, is a directory. Then get back to the same indentation, elif. Then this time we will check for the second condition. The second if condition, elif, is for file. Its initial one is for directory, now it is for the file. So dollar, it's file, close it. Then echo dollar file is a file. Then let me close it. Then let me done it. Yep, let's get back. Chmod o plus x and for wildcard.sh. It's done. Let's execute and see what's going to happen for wildcard.sh. There is some issue, the command not found, dot forward line 6 command not found. Just a minute. What's the issue here? So the problem with this is, I think everything is fine. The script, only thing that I have changed is I've added as it as a path, and then here there should not be any space and no space. So space has been removed. Rest all fine. Let's execute and see what's gonna happen. Yes, that's it. It's clearly saying whether it's a file or directory or not. So that's how things work. That's how you can even read a directory using wildcards. So using these wildcards, you can even get to read the directory completely. What all files are there in it and everything you can read. So now let's move into the while command. The while command is somewhat of a cross between the if-then statement and the for loop. The while command allows you to define a command to test and then loop through a set of commands for as long as the defined test command returns a 0 exit status. It tests the test command at the start of each iteration. When the test command returns a non-zero exit status, the while command stops executing the set of commands. So now let's look into basics of while format. So the test command is defined in the while command is the exact same format as in if then statement. Okay, so while, and then after that you will have a test command. It is similar to if then statement. Then as in the if then statement, you can use any normal bash shell command, or you can use the test command to test for conditions such as variable values. Then the key to the while command is that the exit status code of the test command specified must change based on the commands run during the loop. If the exit status never changes, the while loop will get stuck in an infinite loop. So if you at least know Python or some other language, you would make some sense out of what I was speaking. Okay, then the most common use of test command is to use brackets to check a value of shell variable that is used in the loop commands. And the while command defines the test condition to check for each iteration. For example, you can take an example here. So var1 is our variable and 10 is the value that is assigned to our variable, what variable, and then while is a keyword. Then after that we need a test command or a condition. So for that, the condition expression that we have taken is if is not there, so where 1 greater than 0, that's the condition. Now the while loop stops when the test condition is no longer true. So that is the reason I have compared the test command. I have compared the while loop is a cross of if then statement and then for loop. Here you have a condition, if similar kind of if condition, and then after that you have a loop. So both, but this loop will run until this condition is satisfied, until this condition's exit status code is 0. If it is non-zero, the loop will be broken, and then the loop will be broken, and then it will come out of the loop, and it will be done. So that's how here it is, one example that we have taken. So now let's do one exercise with a simple example. Yep. So vim 60 while dot sh. So this is the simple example. As usual, it starts with shebang and bin bash, the shell, and after that, the first module is while command test. So in while command test, variable 1, the same example that we have mentioned in our slide, I've taken the same example. So 10 is the value which is assigned to the variable 1, and then from here our while loop starts. While is a keyword, and after that we have taken a conditional expression. Obviously an expression would be put in square brackets. We have discussed this in our previous modules. So condition is variable 1 greater than 0. If this condition is satisfied, the exit status code would be 1. If this condition is correct, it is 1, or else it would be 0. That's what happens. Now if it is satisfied, if variable 1 is greater than 0, in this case, if variable 1 is greater than 0, then it will go to the next stage. That's what the whatever commands that you have mentioned in do, that's what, if it is satisfied, then do the following things. The following things is, first echo the variable, and then next you have to set up a expression in such a way that you keep on iterating to the next step or next level, or else it will stuck in in an infinite loop. That's very important. That's very, very important to set up a condition, to set up an expression, to iterate a step up or a step down, whatever it may be. Okay, and then finally done. So let's see what is the output that we will get from it. So but before that, let's give permission for this. So o plus x, and then our file is 60 file. Okay, it's done. Let's execute the file and see what's gonna happen. Sorry, here it is. Start at 10, then the next iteration 9, 8, 7, 6, 5, 4, 3, 2, 1. And once it reaches 1, so 1 minus 1, 1 minus 1 would be 0. So 0 is not greater than 0. So the exit status code is 0. So it's in that loop, in that condition. So it's no more valid, no more, it is not implying with the condition, so it will come out of the loop. So that's what had happened here. So now we will look into using multiple test commands. How can we use that with the while loop? So the while command allows you to define multiple test commands on the while statement line itself. Let's see how can we do that. But before that, the important point to be noted is only the exit status of the last test command is used to determine when the loop stops. This can cause some interesting results if you are not careful. So here is an example. The following is an example that what I am trying to mean. So here, if you take var1 is equals to 10. So while now echo var1, that's one condition. Now I am adding one more condition. That's a var1 greater than 0. And then so two things, this one and then this, and then finally echo this is inside the loop. Then there is a nested uh, condition. Then after that, inside we gave expression, inside the nesting we gave an expression that will iterate one step up or down. So here it is bringing it down one step down. So the first test simply displays the current value of the var1 variable. Here, this is the first test. It simply displays the current value of the var1 variable. The second test, this is the second test. The second test uses brackets to determine the value of var1 variable inside the loop. So an echo statement displays a simple message indicating that the loop was processed. So the while loop executed the echo statement when the var1 variable was equal to 0 and then decreased the var1 variable value. So next, the test commands were executed for the next iteration. So the echo test command was executed displaying the value of the var1 variable, so which is now less than 0. So it's not until the shell executes the test command, so that the while loop terminates. So now what will we do? We will demonstrate this. Then you will get a more clarity. This demonstration that in a multi-command while statement. So all the test commands are executed in each iteration, including last iteration where the last test command fails also. That's what the point to be noted. So be careful of this. Another thing to be carefully consider is how you specify the multiple test commands. Note that each test command is on a separate line. Each test command must be on a separate line. So let me clear the screen, vim, and then we'll do one more example. So this is the simplest example that we have taken in the previous case, but adding a similar example that we have taken what we have taken in the previous case, but here we have added one more condition. Nothing else. We have added one more condition that you can see here. So that's the second condition that we have added. So this time, this echo, this is going to be printed, and then every time this is going to be taken one step down. Okay, let's get out from here and chmod o plus x and 61.file.sh. So 61, yes, that's it. This is what I'm talking about. We have two condition. Even after, because of this two condition, even after 0 there is one more calculation. That's what happens. That's why I told you to focus it more on this part so that you can have a clarity if you run 2. Okay, so next thing we are going to run is vim 6 2 commands.sub. So this is a little complicated one. So first, as usual, shell information, then echo, welcome environment variable user. Here in this case it's a root, and then host name. Then after that just echo normal one. Then free RAM, free RAM, and then gripping the information whatever that you want, and then load uptime. We want only uptime, so this is the one which we want to print, and then root free. So df basically the information, and out of which we are gripping dev sda1 information, and then awk is the another command we put in that pipeline. So after that, the most important thing, all these variables, all these free RAM, load, root free, all these variables we are printing. So just it's a normal exercise, just a fun task, that's it. It's not specifically related to the while. Okay, let me give chmod, and then o plus x and 6 2, yes, and then let me execute the file. Here it is. So available free RAM is 7109 MB. Of course, that's correct. And current load average is 0100, and free root partition size is this much. Okay, that is missed. Okay, this is how you can filter using a grep command the exact information that you want from the commands that you have given using the script. So now let's look into one more loop, that is until. The until command. The until command works in exactly the opposite way from the while command. The until command requires that you specify a test command that normally produces a non-zero exit status. As long as the exit status of the test command is non-zero, the bash shell executes the command listed in the loop. When the test command returns a zero exit status, the loop stops. So that's it. And how does it look like, the loop? It is similar to if then and then mixture. So it's in spite of while, we say until, and then after that we'll give a test command similar to the while loop. Then do whatever that you want to execute. That other commands will come in between the do and done. So that's how it works. So let's take one example, and then we'll execute that example. Okay. So let me clear the screen first, and let me write the file. The file name is until.sh, and I insert mode, then shebang, bin bash, then a bit of space between the next line. Then what this is to test the until command, so it's until command test. Then after that, let's echo some decoration underline. Then after that, let me take var1 as a variable and assign a value of 100 to it. Then let's add one more decoration line to it. Then let's begin our loop until, then condition. So basically I will take var1, if it is equal to 0, then what I want to do, what I want my bash to do is echo that var1, and then I need a expression to keep the iteration process going. So that is var1 minus 25. So this, maybe I get 4 or 5 times, 4 or 5 iterations. Let's see. Okay, it's all done. Let's type done, and then a bit of decoration, colon is done. Then final decoration, that is under a line. That's it. Let me save and quit it. Let me save and quit it. Now let me give the permissions to that chmod o plus x and until dot sh. Okay, what's the issue? Until dot sh. Then let me execute the file and see what's happening. Here it is. Here it is. Oh, something is missing. Something is missing. Let me check. Let me come out of the loop. I came out of the loop. And then, yes. Where 100 done equal it's fine. Yep. Line 12, something is missing. Control C. Oh, sorry. Oh, what? Line 12, go do where? Where 1 is fine. Where 1 equal and then the file name what we have named is and then 7. Yep. So vim yep, I got it. So this is the output that we got. 4 time. It's been because 25 what we have taken, and as I have told you before, 4 times it's been iterated through that. Then so the next thing for us in pipeline is So similar to the while command, you can also have more than one test command in the until command statement. Only the exit status of the last command determines if the bash shell executes the other commands defined. Okay. So now let's take an example with the multiple commands. So the following example consists of an until loop with the multiple commands, and this example tests the var1, that's a variable to determine when the until loop should stop. As soon as the value of the variable is equal to 0, the until command stops the loop. As soon as, that's what it's opposite, exactly opposite to the while loop. As soon as the value of the variable is equal to 0, the until command stops the loop. So within the commands, if you want, within the commands, the variable used in the test command must be modified, or you will have an infinite loop. So echo var1 and then expression to bring it down. So that's what. So here is that example, and the same caution as for the while loop command applies when you use multiple test commands with the until command. Sorry. So let me create the file vim. It's until dot. Okay, vim 7. Yes, if you take we have considered by and large same example, but here we have added two conditions, condition 1 and then condition 2. So echo inside the loop, then where and then where 1. Okay, so let's execute this as we have discussed the logic before. So chmod and o plus x 7 1 until dot sh 7 1 until dot sh. That's it. This is how you use a dual condition to get the dual output for the each iteration. 100 inside the loop, 100, then 75 inside the loop, 75, 50 inside the loop, 50, and then inside the loop 25, then it ends with a 0. So 0 is equal to 0. So now until loop is done and dusted. So now let's do a most widely done activity in Linux, that is looping on file data. So often you must iterate through items stored inside a file. This requires combining two of the techniques that has been covered so far. So one is using nested loops changing, and second one is the ifs environment variable. This is very important. Ifs environment variable, that's capital I, capital F, capital S. Sorry. So by changing the ifs environment variable, you can force the command to handle each line in the file as a separate item for processing, even if the data contains spaces after you have extracted an individual line in the file. You may have to loop again to extract data contained within it. And the classic example of this type of processing or looping on file data is basically looping the data in etc pass wd file, because this is widely done activity. So that's the reason I have taken this example. This requires that you iterate through the forward slash etc forward slash for pass wd file line by line. Literally I'm saying line by line, and then change the ifs variable value to a colon, so you can separate the individual components in each line. I'll show you, directly with an example, and then I'll explain. So before that, you just go through the code here once, and then we will jump into the example or an exercise. So ifs.old, so this is our environment variable, that's ifs, and then for is our keyword, entry is our iterative variable, in is our keyword. Then after that we have a cat, the concatenation, and then forward slash etc forward slash pass wd, that's where our file lies, so that's the location we have given. After that, you do what you have to do, echo values in entry, each line, echo each line in that. Then the most important thing, we have equated our ifs, that is our environment variable, as a colon. So now what does it says, you separate the value based on the colon, you divide the values based on the colon. So and then and one more inner loop for value. So this time each line will be separated, each line will be bifurcated into different words based on colon, based on ifs environment variable. That's the inner for loop. Again here we are using nested loops only. Let's take an example and let's run it. Vim 90 loop file.sh, I insert mode as usual, the first one. Then after that, changing the ifs value. So ifs, here is the logic that I'm talking about. ifs is equal to colon. What does it mean? Here the ifs variable value to a colon, so you can separate the individual components in each line which are separated by colon. If you see the pass wd, each line, basically each line is separated by a forward slash and backward slash, and that is the reason our first ifs for the main for loop or outer for loop is backward slash n. But whereas inside the line, each word is separated by the colon. That's the reason ifs variable takes the colon here. So now this is the, with this logic we are reading through the line first, and then we are iterating to the each word, and we are bifurcating the each word based on the colon. That is the logic of this snippet, this script. Let's execute and see. Before we execute the script, let's give a permission to the cell to execute it. So it's a 9 loop, and then 9. That's it. Here is the information what you are expecting. 1001 home test, everything. Initially it was separated by line, and then each line has been further divided into words based on colon. You can see I will go up, I'll find out the first line, I'll scroll up, and then I'll find out the information about the root user. Let's hope it may take more time, I guess. Should I continue? What do you guys suggest me? Should I continue or should I stop it? Should I keep scrolling up, or what should I do? Okay. Yep. Here is the first one. If you see it, the first one values in root, and after that this one is completely bifurcated into root, and then x and 0 based on the colon. Okay. So this script uses the two different ifs, just to give more understanding about that, this script uses two different ifs values to parse the data. The first ifs value parses. What it does, just a minute, I'll put the script here on right side because it would be helpful. Yep. What the first ifs value, look at here, this point. The first ifs value parses the individual lines in the forward slash etc forward slash pass wd file, and the inner ifs, what it does is, the inner for loop next changes the ifs value to the colon, so which allows you to parse the individual lines within the forward slash etc pass wd line. So this is how we are able to separate the each word in that pass wd file. When you run this script, we got by and large this kind of information. Now let's nest all the loops together. So a loop statement can use any other type of command or loop within the loop, including the loop commands. So this is called a nested loop. Care should be taken when using nested loops, because you're performing an iteration within an iteration, so which multiplies the number of times commands are being run. If you don't pay close attention to this, it can cause problems in your script. So let's take an example, a nested loop. Here in this loop, a for loop inside another for loop. That's the example is displayed on your screen. So first one is for loop, and after that do, and inside that echo, and inside that there is one more for loop, and then and again one more do, and closing done for the first for loop. So let's do an example exercise, then after that we'll go to the next examples. Let me clear the screen first. So vim 80 nesting, and then as usual insert mode bin bash, and now testing and nesting for loop. First outer for loop or main for loop, then after that if you see this is a nested for loop. So nested for loop, total we have two for loops. Okay, let's execute this and see how does this work. So chmod o plus x 80 nesting, yes, that's it. So starting loop 1, this is inside loop 1 2 3, again starting loop 2. So this is the main for loop, and this is the nested for loop, main for loop, nested for loop, main for loop, nested for loop. So basically the nested for loop has been reiterated 3 times. That's how a nested loops works. Here a nested for loop for a for loop. The nested loop also called the inner loop. So simply we can say the outer loop as well as outer loop and inner loop. So here we call it the nested loop as a inner loop. Inner loop iterates through its values for each iteration of the outer loop. That's what happened with our example also. Notice that there is no difference between do and done commands for the two loops, whether it may be outer loop or inner loop. And the bash shell knows when the first done command is executed, that it refers to the inner loop and not the outer loop. The same applies when you mix loop commands, such as placing a for loop inside a while loop. Now let's take an example of a for loop, uh, a for loop as an inner loop and a while loop as an outer loop. Okay, so you can see the example that's exactly in front of your eyes on your screen. So var1 is our variable, and then while loop is our outer loop with a condition, that's a var1 greater than or equals to 0. If that's the case, do done, echo outer loop variable 1. Now for the first iteration, I think we will have a 5 iterations. Okay, yes, we'll have a 5 iterations, and for 5 iteration the for loop is going to be executed how many times, that we will see. So for loop, I think same we have given. So for loop will be executed 5 times, and for loop iterations will be taken place each and every iteration of while loop. So this is the example that we have considered, and let's done it. Okay, so now let's take an example for the same. Let's run an exercise on the same. So let me clear the screen first, and then vim, this time it's 8 1 nesting.sh. Yes, this is our example, while outer loop and for inner loop. The same logic that we have discussed in our slide, the same one is been running here. The same logic, placing a for loop inside a while loop. So this is our while loop, but the thing is f, I have to remove this f. Yeah, now it's a var1. So var1 and then outer loop var1. So here we use var2. Yes, rest all remains same. Let's execute, let's give permissions to the shell to execute it. So o plus x and then 8 if underscore 1 nesting done. Now 8 underscore 1 nesting dot sh. That's it. It's huge data. Of course there is a lot of stuff in it, that's the reason. Okay, so outer loop is 5. First it started with the outer loop 5, then inner loop, again inner loop. So that's how. There is a lot of stuff. Okay, readme website, lot of stuff is there in it. That's how it works. Let me clear the screen. For and while loop, because we have used a for loop inside a while loop. So then again the shell distinguished between the two and done commands of inner for loop from the same commands in the outer while loop. If you really want to test your brain, you can even combine until and while loops. You can do the permutation and combinations of these for, while, until, all the loops together, and you can play around. So the another example that we have considered is until, and then the inner loop is while, until while. The same example, directly let us run that and we'll see what's going to happen. Okay, I'm sorry. Yep, here it is. So vim 8 2 nesting.sh. Yep, it's here it is. Outside it's until, and then inside we have a while loop. And let's run it and see. There is a calculation, integer calculations also using pipeline, and then BC, that's a bash calculator. And let's see what is the result that we are going to get, and how many. I think 3 iterations of outer loop, and inside we'll see how many iterations we can get. I think it's 4. Let's see. Before that we'll give permissions. 8 2. Oh, I think something is wrong with the inner loop. That's fine. In inner loop, some command scale 4. Okay, that's the issue. Some command not 4. That's fine. That's fine. The calculation is missing. That's okay. But the logic by this moment, you would have gotten the logic. So that is our main motto. So far we have seen loops and nested loops and looping through the file. A lot of stuff. Lot means a lot. So now let us look how let us uh, see how to control the loop. How to control the loop, that's it. So it's called in controlling the loop basically. So you might be tempted to think that after you start a loop, you're stuck with the loop, and loop finishes all its iterations. That is not true. A couple of commands help us control what happens inside a loop. The first one is the break command, and the second one is the continue command. If you are a Pythoneer or Pythonista, you might have heard about these break and continue in Python also. So each command has a different use in how to control the operation of a loop. The following section basically describes completely about how you can use these commands to control the operation of your loops. So before that, let's take one exercise, and then we will get back to the uh, first command. First, okay. So vim, yep, this is our breaking out of a loop, breaking out of a for loop. This example we are going to do, but before I talk about the break command, I just want to show the code. I just want to show the snippet of the break loop, and then we will get back to the breaking of a loop. Okay, breaking into a loop or breaking of a loop, whatever you want to say, you can say. That's not an issue. So here, this is a for loop. So for loop variable is one is our iterative variable, then in, and we have a list of numbers 1 to 10. Okay, so now do in that we have an if then statement. If has a condition, if variable 1 is greater, if variable 1 equal to 5, then break from the if then break from the loop, and then completely get out of the loop. Simply what I want to do here is, the problem statement for me is, I just want to iterate only 5 times. I have a specific condition. Once it reaches to 5, I just have to stop the loop. That's how can I do that? With the normal loop, it's very difficult, or you have to put nested loops. Even that time also we can't do that. So in that case, this break will come in handy. This is the problem statement. This is the problem or challenge that you can solve using break. So as you have seen one problem and or challenge, and we used a break to solve that problem or challenge. Now let's look into the break command. What is the break command? So the break command is a simple way to escape a loop in progress. That's what a break command is. The simplest and well defined definition for the break command is it's a simple way to escape a loop in progress. So you can use the break command to exit any type of loop, including while, until, even those loops also it works. And breaking, let's look into breaking out of a single loop first. When the shell executes a break command, it attempts to break out of the loop that is currently processing. So uh, if you take this example, the same example that we have shown in our exercise, so the same example, so once once it has to come out, in that case the for loop normally the for loop should normally have iterated through all the values specified in the list. However, when the if then condition was satisfied, the shell executed the break command which stopped the for loop. That's how the break command helps out you to break out from a loop. Let's do an exercise first and we'll see. The same example we'll take, as we have discussed about this. Let's give permission to execute, and this is 10 0. Done. Let me clear the screen, and then 10 0. Yes, that's it. See, if in a normal case it should have has 5 iteration, it should have had 5 iterations, but in this case it had only only 5. Sorry, in the normal case it should have had 10 iterations, 10 iterations, but because of that break, it has broken after the fifth iteration. The fifth iteration, it has given the for loop is completed. The for loop is completed. This is how a break command or break helps a lot, a lot. Then we have breaking out of an inner loop. So breaking out of an inner loop. So when you are working with multiple loops, the break command automatically terminates the innermost loop you are in. Okay. So let's look into this example also. Let me put it on left side for your convenience. Then Vim. Sorry. Yep. This is our loop breaking out of a while loop. This is a normal example. In the next case we'll take the inner loop, but even this one also we can just execute and see. The same logic goes here also. It's ch mode o plus x 10 1 and then 10 1. Yes, that's it. The while loop is completed. Iteration 1, iteration 2, iteration 3. So now let's look into a logic where you can break out of an inner loop. So this is the logic that we have used. A for loop, a is equals, the condition is a is equals to 1 and a is less than 4 and a plus plus. This is the condition maximum. We should have a 3 to 4 iterations, and after that, that is our outer loop. Then you have an inner loop, one more inner loop, and inside that inner loop we have used if then statement to attach a break. So that's what here we want to break this inner loop. This part we just want to break this inner loop, inner for loop, exactly this one. Okay, so let's wq and then chmod o plus x and then 10 to yes, that's it. Let me clear the screen to see. Normally it should have gone the inner loop. I'm talking about only inner loop. Here you can see the loop logic because I used the same example. So normally it should have gone till 100 because b equals to 1 till 100 and b plus plus. So you add 1 1 1. So it should have gone till 100, but we have 3 outer iterations, whereas inner loop we have only 4, because that's the logic we have given. Here if we have said if the b value is lesser than, oh sorry, if b value is equal to 5, once it reaches the 5, you just break the inner loop. So the inner loop has been broken, or else it would have continued. Let's let's do some changes in the inner loop, and let's execute and see what's going to happen. So what I will put is the condition, I will put it till 55, and we'll see what's going to happen. Same one, let's execute. See, that's what the magic. I don't want to this is too much. This is too much. It's too much, but still I'll show it. Still I'll show it. Okay, because it's all fun. So basically, as a software engineer, that's where I get a fun. It's fantastic. So uh, this is our outer loop 1, and inside that, how many we have? We have 54, or close to, or 55 inner loops. 55 inner loops. That's how the break helps. Wherever you want to break, you can break out of. You can break out easily. So that's what, it's much easier than break up in real life. Okay. So basically this the break command helps a loop to break out from the from its relation. So, and we have outer loop, second outer loop, and again inside that we have 54 inner loop iterations, and then third outer loop, and then we have 55 inner loop iterations. This is how you can even break out of an inner loop. Then finally we will look into breaking out of an outer loop. So there may be times when you are in an inner loop but need to stop the outer loop. So in that case, the break command includes a single command line parameter value. That's it. So this is the logic. We'll use the same code, but here we will add a loop to the outer one. Let me clear the screen first. Vim 10.3. Here it is. This is for inner loop. Chmod O plus X 10.3. That's it. That's it. Your outer loop has been, of course, inner loop has been broken, but we have broke the outer loop also. You can see that before we used to get 3, but here it's just 1. Just one. Just one. That's it. This is our outer loop, and then outer loop has been broken for only one. Only one. Just only one. And one more, Vim 10.4. So this is one more example using the continue command. Just a minute. So now we'll take one more example using the continue command. So the continue command example, we'll just go through it. We'll just go through it code first. So here for loop, from 1 variable 1 and till less than 15, and it should be incremental by 1 1 1. Then inside we use the if logic, and then the logic is that's why the continue would be very important, whereas the break is to break out of the loop, whereas continue is to continue at a certain uh, logic, at a certain condition. There you want to run it, till that you don't want to run it. In that case this helps. See here what happens is variable 1 greater than 5 and also variable 1 less than 10. If only in this condition, that means you just want to run this loop in between 6 to 9. In only these only these two conditions are complied, then only you want to continue the loop. It's not breaking the loop, it's continue the loop, it's running the loop based on a condition. That is the benefit of loop continue command. So we have seen the we have deciphered the snippet. Now let's give the permissions, and then after that let's execute the code. Here it is. See, it has run, of course, 14, but it is continued after a certain stage. After a certain stage, that's what it's continued after a certain stage. So next we have one more example, that's control loop with the continue for the outer loop, only for the outer loop. Let's go for that also. 10 5. So this is the code, and then this time continue 2 only. Okay, this for both continue 1 and continue 2. And the logic here we have given, if the a, this is for the outer loop, if a outer loop variable a greater than 2 and then a less than 4, in these two conditions only you run it and you continue the. So let's change the mode first, and o plus x 10 5. Yes, almost everything. So this is how break and continue controls your loop. Now that you have seen how to use the different ways to create loops in shell scripts, let's look at some practical examples of how to use them. Looping is a common way to iterate through data on the system, whether it is files in folders or data contained in a file. The following are a couple of examples that demonstrate using simple loops to work with data. The first one is finding executable files. What happens when you run a program from command line? The Linux system searches a series of folders looking for that file. So those folders are defined in the path environment, capital P, capital A, capital T, capital H. It's an environment variable. Now, if you want to find out just what executable files are available on your system for you to use, just scan all the folders in the path environment variable. So that may take some time to do manually, but it's a breeze working out a small shell script to do that. So the first step is to create a for loop, and then to iterate through the folders stored in the path environment variable. When you do that, don't forget to set the ifs separator character. So let's look into the code. So ifs, and then for folder in the path do. So now that you have individual folders in the folder variable, so you can use another for loop to iterate through the files inside that particular folder. and after that you can add if then, and finally you separate all those based on the colon. Okay, when you run the code, we'll run the code and we'll see it. So it's vim and it's 11. Okay, so bin bash, and after that the first thing that we have seen is ifs, it's colon, so we just want to separate based on colon. Then first for loop, that's our outer loop consists of uh, iterative variable folder, and then path environment variable we have taken. Now whatever folder that is there in that path environment variable, all will be scanned in different iteration. If there are 150 number of directories, 150 number of folders of files which are present in that path environment variable location, and all will be scanned, and that many number of iteration this loop is going to run. And after that uh, we use that echo of that path, whatever that folder you got it, and then we run a inner for loop. That will scan that folder itself, that folder, and whatever number of items or entities are there inside that folder, and then we will do the if then statement, where we will check whether it is a specific type of executable file or not. When it say x, we will check whether it is a executable file or not. If it is executable file, and finally you print that executable file and then close the loop. So that's what it's a very useful snippet we widely use while doing work in a Linux system. So just focus on this. So 11, here it is, it's keep on running, the magic is going on, it's scanning each and every folder, and then once scanning a folder is done, and it will scan each and every item in that folder, and after scanning each and every item, it will look for the binary files, basically executable files. We say executable files. Once it gets all the executable files, all the iterations will be done, then it will close it. So finally you got the executable file. See, snap bin lxc lxd, so these are all in binary files, these are all executable files. See, here you can see terraform.exe, that's also executable file. So these are all executable files. This is how you use with the 4 to 5 lines of code, 5 lines of bash script, you have completed a work within 10 seconds, which supposed to take 5 hours. 5 hours to search and enter into each directory, each folder, to find out the binary files. This is how it helpful. Let's look into one more practical example, and the most widely useful practical example is creating multiple user accounts. So instead of having to manually enter user add commands for every new user account you need to create, you can place the new user accounts in a text file and create a simple shell script to do that work for you. So the goal of shell scripts is to make life easier for the system administrator. If you happen to work in an environment with lots of users, one of the most boring tasks can be creating new user accounts. Fortunately, you can use the while loop to make your job a little easier. So the first entry is user ID you want to use for a new user account. So you need to create So the second entry is the full name of the user. So the two values are separated by a comma. So making this a comma separated file format or .csv. So here is that vim users.csv. So I will add few more a few more users here, and sorry, this comma separated, and one more the final user. So this is the user .csv file for us. These are the users we want to add to our system. This is a very common file format used in a spreadsheet, so you can easily create the user account list in a spreadsheet program and save it in .csv format for your shell script to read and process. So you can just go through the shell script once, but we'll directly first line. The first line talks about uh, to read the file. This line to read file data. We are going to use a little shell script trick here. We will actually set the ifs separator character to a comma as the test part of the while statement. Then to read individual lines, we will use the read command. We will use the read command. So this looks like this. So the read command does the work of moving into the next line of the text in the .csv text file. So we don't need another loop to do that. The while command exits. The while command exits when the read command returns a false value. So which happens when it returns out of line to read in the file. So let's take this example. This is the final script that we added, and then the input is the variable points to the data file and is used as the redirect data for the while command. So the user.csv file looks like that I have already shown it to you. Basically, to run this problem, you must be the root user account, or else it's very difficult to deal, because a root user account only can have this access. Because we are using user add command, this utility belongs to this is admin level utility, so that's why you need root user account or root user privileges to run this problem. So then, by taking a quick look at etc, and that's the final. So let me get into this one. So vim 11 1 prac dot exe. So this is our complete piece of code. So this is the code that we have discussed. Read it reads each line from input. So here we are redirecting the input, and first one is user id and second one is name. And after that we are entering into the while loop, adding user id. So this is the actual command, user add command, and then see, this is the name and this is the user id. So both name and then user id. Name you get it from there, and user id, and finally once it is done, let's execute it and let's check that. So once all set, just go to the just have a quick look at the etc pass wd file. You can see that accounts that have been created recently. So just to give a quick summary of loopings. Looping is an integral part of programming. The bash shell provides three looping commands that you can use in your scripts. The first one is for loop. The for command always allows you to iterate through a list of values either supplied within the command line or contained in a variable or maybe obtained by using a file globing to extract file and directory names from a wildcard character. And we have the while command. The while command provides a method to loop based on the condition of a command using either ordinary commands or the test command, which allows you to test the conditions of variables as long as the condition produces a zero exit status code. So the while loop continues to iterate through the specified set of commands. And the next one is the until command. The until command always provides the until command always provides a method to iterate through commands, but it bases its iterations on a command or condition producing a non-zero exit status. So this feature allows you to set a condition that must be met before the iteration stops. And you can combine loops in shell scripts producing multiple layers of loops. The bash shell provides the continue and break commands also, which allows you to alter the flow of normal loop process based on the different values within the loop. So that's what controlling the loops. Similarly, the bash shell also allows you to use a standard command redirection and piping to alter the output of a loop. So you can use a redirection to redirect the output of a loop to a file, or piping to redirect the output of a loop to another command. That's what we have done in our last uh, the earlier example. So this provides a wealth of features which you can control your shell script execution. So far you have seen how to write scripts that interact with data, variables and files on the Linux system. Sometimes you need to write a script that has to interact with the person who's running the script. So the bash shell provides a few different methods for retrieving data from people, so including command line parameters, so such as data values added after the command. So uh, uh, command line options like single letter values that modify the behavior of the command, and the capability to read input directly from the keyboard. So here we will discuss how to incorporate these different methods into your bash shell scripts to obtain data from the person who's running your script. So so let's begin with the reading basics. It's called a read. So there it's input, but we call it as a read. So the read command accepts, basically the read command accepts input either from standard input such as from the keyboard or from another file descriptor. After receiving the input, the read command places the data into a variable. So here is the example, the simplest example that you can see on your screen. So uh, here what happens, it's pretty simple, but what you can see here is, notice that the echo here, echo, just look at here on the pink cursor, echo echo command that produce the prompt uses an option. So this suppresses the new line character at the end of the string, so allowing the script user to enter data immediately after the string instead of in a next line. So this gives you script this gives your scripts a more form like of appearance. So this echo, this is where it collects the data and then read name. So it will read it and then it will print it like this. Okay, let's go for our first exercise in handling user inputs. Vim user input.sh, and this is our first example. So bin bash, so testing the read command. So echo, these are first two echoes are for decoration purpose. Then after that, what we have is our first is enter your name. Just echo enter your name. So whatever that you enter here, just a minute. Okay. Yeah, whatever that you enter here, that will be read and that will be taken and that will be stored in name variable. The variable name is name. So then you can use that as a name, as a variable in your next printing. So I just want to print hello, the name, and welcome to my program. This is how we handle the input. So let's give permissions to this and then we will execute and give some input and we'll play around. So chmod go plus x and it's 12 0 user input dot sh, and um, we have given the permissions to run. So let's clear the screen first and then execute that file. Yes, it's asking name, so I'll give Charan first. Let's see what's gonna happen. Hello Charan, welcome to my program. Fantastic. So again I will execute the same file. This time I will give a girlfriend's name, that's Divya. So yep, hello Divya, welcome to my program. This time I will give one more other name, other girlfriend name, that's Daksha. Sorry, Daksha. Yep, hello Daksha, welcome to my program. So similarly, you also give your name and your girlfriend's name and girlfriend's name, everything, and just play around. So that's how you can handle your user input. So then we will move a step ahead. That's what in this case, in fact, the read command includes the p option, which allows you to specify a prompt directly in the read command line. So this is what happens if you use a p option. So if you use a p option, it directly reads in spite of using this read and then a name variable. It will directly reads whatever that you mention, and then you can add that variable name itself here. Okay, so and then you can do any arithmetic operations and finally you can print the output that you want to print. So let's go for this exercise now. So let's type this exercise and do it. Okay, mm, we'll go for this exercise. It's 12. Yep, so let me get into our WSL. Let me clear the screen and then vim, the name is 12.1 user input .sh, and shabang. Yeah, what's the issue? String cursor. Yep, bin bash So here what we want to test is testing the read with p option. Yep. So let's do some decoration first. A line, then our colons. So enough decoration. Yep. So now let's read using p option. So ask, please enter your age. Yes, and then close the, and the value that you enter here should be assigned as a value to the variable name age. That's what I'm mentioning here. So now I'll do some calculation. So with the day, with the days variable, so I'll put it down. Days is another variable. The value should come from the following expression. That is, as it is an expression, we'll use a square brackets, and then dollar age we get from top, and then you multiply with the 365. That's the days. So then, so what you get is, and finally what you want to print is uh, that makes you over this. Days is a variable, days old. So I just want to print how many days old you are. That's it, nothing much. And then let me decorate back. Yeah, let me close it, and then ch mode as usual, o plus x, and then 12 one user input, and then let me execute 12 one user input. It's asking my age. I will say 27, and it has to do calculation, but it did not. It's supposed to do, but it did not. Yes, finally it has done it. That makes you over 9,855 days old. Fantastic. Let me calculate for my girlfriend too. That's okay. So she's 25. Oh, 9,125 days old. Brilliant. For my faculty, 56. That makes you over 204402. I think 20,440 days old. That's huge. That's huge. If you want to do for your friends or your girlfriend or your family members, you just do the calculation here. That's nice, no? Yes, it's fun. Fantastic. Yeah. Then you will notice in the first example that when a name was entered, the read command assigned both the first name and last name to the same variable. So the read command assigns all data entered at the prompt to a single variable. So, or you can specify multiple variables. So each data value entered is assigned to the next variable in the list. So if the list of variables run out before the data does, so the remaining data is assigned to the last variable. So this is how it works. So for that we have taken another example. Here you can see that. So entering multiple variables, read and p, enter your name. So first, last, basically we have two variables here, two variables. So if you enter only two lines, oh sorry, two words, then first word will go to the first variable named as a first, and second word will go to the variable named as a last. That's it. So okay, let's do it. Let's write a piece of code and let's check it. What's gonna how it's gonna work. It's Yeah, let me clear this first. Vim 12.2 user input .sh. Bin bash. This is entering multiple variables. Echo, the decoration begins. I hope you like my decoration. And then colons, decoration begins. Okay, so then let's read. So p, enter your name. So, and let's close the braces, let's close the quotation, and then two variables we have defined, first and then last, and then echo, then checking data for data for two things. That's one is last name and other one is first, and let's close it. And decoration again, echo and then echo underscores, close it. Let's chmod o plus x and 12 to done, and then 12 to, let's enter Surya Charan. So checking data, Surya Charan is last and Surya is first, whatever the way you give. So this is the last one, and then this is how it takes. Let's see if I give three names. Of course my name is very big, so I'll give all the names that I have. So what it will do, let's see. This is my full name. Yeah, just a minute. This is my full name. Yeah, this is my complete name. So I have entered my complete name, and let's see what's going to happen. Yep, so only the first one has been attached to the first name. Rest all words has been attached to the last, the variable named as last. For that variable all others has been attached. I will test for my girlfriend also. Okay, Dakshayani, Sri and Dakshayani. Okay, that's fantastic. You also play around. It's nice to play around with the software uh, coding. So basically programming or coding of software snippets or application snippets. It's nice to play around. I really like it. I spend most of the times and playing around with the software snippets. So you can also basically specify no variables on the read command line. If you do that, the read command places any data it receives in the special environment variable reply. So this is the one where we haven't mentioned anything, any variable name, and let's see what's going to happen with this. Vim 12, that's a 3. Okay, sorry. And then Vim 12.3 user input, and here you can see that read and p option, enter your name, but we haven't given any variable name. So but here we have used a environment variable. So a reply, and let's see what's going to happen. I think it will work because its environment variable will automatically take if you don't give, because that's the reply that that a user is giving. So let's see, let's execute this, and then let me clear the screen first and let me execute this. Yes, it's asking name. I'll give Charan. Okay, hello, welcome to my program. The problem is read name not a valid identifier. Okay, okay, maybe there is something wrong with the code. Okay, just a minute. Read, enter your name. Okay, I got it. The problem is, yeah, let's see. Yeah, it's asking enter your name. Hello, Charan, welcome to my program. Without any variable, without any variable mentioned there. Yep, yep. So that's how you also play around. So finally, here in this case, the reply variable, the reply environment variable contains all the data entered in the input, and it can be used in the shell script as like any other normal variable. So be careful when using the read command. So your script may get stuck waiting for the script user to enter data. If the script must go on regardless of whether any data was entered, so you can use the T option to specify a timer. So the T option specifies the number of seconds for the read command to wait for input. So when the timer expires, the read command returns a non-zero exit status. So what's the benefit or because of this? Because the read command exits when a non-zero exit status if the timer expires. It's easy to use the standard structured statements such as an if-then statement or a while loop to track what happened. Let's take one example. Let's take one example. Uh, the example that you see on the screen. If you take the same example, in this example, when the timer expires, so here it is, we have put it 5 seconds. When the timer expires, it says mm, uh, when the timer expires, it says the read command returns a non-zero exit status. So because of that, automatically this if statement fails, and then shell executes the commands which are there inside the else. Okay, so let's go to our WSL, and then we'll create Vim. This is for user input timeout. User input timeout.sh, and then let's begin with shebang and then bin bash. So let's add a comment first saying uh, this is to test the timing out of the read command. Then let's begin. We'll begin with the if statement, and then a read command we will add, and we'll put the time option, the timing out option. We'll put it 10 seconds first. I think 10 seconds. We'll start with the 10 seconds, and then a P option, so that we can write the variable in the same line. Then let's write the matter that you want to display to the user. Please enter your name. name, and then close the quotation. Then variable name, I want to give name only, and then if this happens, echo what do you want to echo? Hello dear, and then name variable, welcome to my world of scripting, or bash scripting is better, bash scripting, and then let me close it. So then the final one is else. If it expires, if the time expires, if time gets out, then what we want is echo sorry, sorry, the time is up, time is up, the time is up, or the time's up, whatever you want, you just type it. And uh, let's close the if then statement with fi. So all set, all done. Let me give wq, that's save and quit, and press enter. But before that, let me give the permissions to this. So o plus x, that is giving executing permissions to others. So shell is comes under the others only. So then my file is ui timeout.sh. So permissions are given. So if you want, you can check it. ls lrt pipe grep ui, that's it. You can see it here, the permission is given. So now let me execute UI. So it's asking to enter my name. I'll just wait for 10 seconds. I think by this moment 3-4 seconds were over. So 6, yeah, it's up, it's up, the time is up, the time is up. So now we did not get stuck uh, in that screen. We did not get stuck with the one command. So once the time is up, as usual, it will run the next task. It will run the next commands that are presented inside, that are written inside that file. So now again I will run it, but this time I'll try to give my name before that. I think 10 seconds would be little lesser. It's better to increase the time by 15 or 20 seconds. Let's see. So now let's increase the time a bit higher. We'll take it upper side, yeah, here. So I'll make it 10, it's 15, it's 20, yeah, it's 20, no, 20 is fine. Escape and shift colon WQ and enter. So now let me execute. So this time I got enough time, so I'll type Charan. Hello dear Charan, welcome to my world of bash scripting. But this time I'll give my girlfriend's name. So Dakshi or Daksha or Daksha or Daksha. Hello dear Daksha, welcome to my world of bash scripting. You also give your girlfriend names or your friend's name or whoever you want, and you just have some fun with this. The last point that I want to make here is, instead of timing the input, you can also use some other methods to tackle this problem. So you can also set the read command to count the input characters when a preset number of characters has been entered. So it automatically exits assigning the entered data to the variable. So in this slide, I will expand on the topic of redirection by showing you how you can redirect the output of your script to different locations on your Linux system. So let's begin with understanding input and output. So far you have seen two methods for displaying the output from your script. The first one is displaying the output on the monitor screen. That's the one way. Second one is just redirect the output to a uh, to another file. So basically it's like whatever output that you get from this command, we are redirecting that output to either another file. So we'll save that output of this command into that file so that you can use it. These are the two ways we are doing so far. So both methods produced an sorry, both methods produced an all or nothing approach to data output. So there are times, however, when it would be nice to display some data on the monitor and other data in a file. For these instances, it comes in handy to know how Linux handles input and output. So you can get your script uh, sorry, get your script output to the right place. So let's begin with the standard file descriptors. So let's go through the points one by one. The first point in standard file descriptor is uh, the Linux system handles every object as a file. This is very important. I have been repeating this sentence as a broken tape recorder for almost uh, along this course. So every object in a Linux system is like file. So the Linux system handles every object as a file. So this includes the input and output process also. So Linux identifies each file object using a file descriptor. So this is very important point to be noted. Then the file descriptor is a non-negative integer, so that uniquely identifies open files in a session. So each process is allowed to have up to 9 open file descriptors at a time. So based on this logic, so the bash shell reserves the first three file descriptors, the 0, 1 and 2, for special purposes. Just note down these three digits, 0, 1 and 2. These three file descriptors has been designated for special purposes. What are those special purposes? We are going to look about these things in forward sessions. So these three special file descriptors handle the input and output from your script. So the shell uses them to direct the default input and output in the shell to the appropriate location, which by default usually your monitor. So this is the information about those three file descriptors that have been speaking about, that have been mentioning about. So file descriptor, the first one is 0. 0 means abbreviation is std in. Simply we can say standard input. So for file descriptor 1, the abbreviation is std out, we call it as a standard output. Whereas the file descriptor 2, abbreviation is stdr, and the description is standard error. Just remember this three file descriptors. These are very useful. Most of the scripts that we use in our real cases, we use these file descriptors heavily. We use these file descriptors. That's why please keep an eye and check these file descriptors into your brain directly and store it in your brain. This will come in a handy when you're working with your deployment. So let's begin with std in. uh, the std in the std file descriptor references the standard input to the shell. For a terminal interface, the standard input is obviously and always it's a keyboard. If it is our laptop, it's a keyboard. Uh, it's a whatever keyboard that we have for a laptop. If it is a computer, we'll have a separate keyboard which can be connected through either USB, or you can also have a wireless keyboard. So that is our standard input. So the shell receives input from the keyboard on the std in a file descriptor and processes each character as you type it. So when you use the input redirect symbol, that symbol I'll show it, symbol, so Linux replaces the standard input file descriptor with the file referenced by the redirection. That's what the important points to be noted here. So it reads the file and retrieves data just as if it were typed on the keyboard. So that's the main point. And then many bash commands accept input from stdin, especially if no files are specified on the command line. So you can see an example on your screen, in this screen, using the cat command with the data entered from stdin. So here we have used a cat. So basically cat is to read a file. So when you use a cat, this is a test. Basically whatever that you type can directly display on the screen. So this is the best example to showcase your std in. So then what we are going to look into is std out. So mm, okay, before that we will look into this example. So when you enter the cat command on the command line itself, on the command line by itself, so it accepts the input from stdin. So as you enter each line, the cat command echoes the line to the display. So let me show it. That's fine. Let me clear the screen first. Cat, what do you want to type now? I'll type the same one. This is a std in test. This is a std in second test. Okay, you got it. Hence it's been proved. However, you can also use the std in a redirect symbol to force the cat command to accept input from another file other than std in. So that's also we are going to do. So for that we will create a test file. Sorry, I'm in a wrong yeah, I want to select this one. Yeah, let me clear this first. Okay, but I have to come out of the cat one. Yeah, so let me create a test file. In test file, okay, this is the I love Linux, I love bash, I love Ubuntu, cat. Here it is. That's how it works. So basically we are redirecting uh, the input from test file to the cat. So now what cat will do? Cat will display. So basically std in. So here we use the std in redirect symbol. This is that std in a redirect symbol to force the cat command to accept input from another file, that is our test file, to uh, uh, to basically display. And then so and finally what we have is std out. So the std out file descriptor references the standard output for the shell. So on a terminal interface, the standard output is basically the terminal monitor. So whatever that we see in front of our eyes, that's the standard output. So all output from the shell, including programs and scripts you run in the shell, is directed to the standard output, which is the monitor. So now in spite of that, we want to direct to somewhere else. So there, standard in is the standard input, that's through keyboard, whereas here standard out, the standard output is directed to the monitor. So most bash commands direct their output to the std out file descriptor by default. So you can change that using output direction. So let's take one example here. So let's do ls lrt, and we will redirect the output of this command to the std, just a minute, std out dot txt. So let me catch std out dot txt. That's it, that's it. In spite of normally the standard out, basically this symbol is standard out symbol and this symbol is standard in symbol. In this case, standard out symbol, in spite of directing to the monitor, it's directing into this file, whereas in this case, in spite of taking input from the keyboard, it's taking input from the test file and put it and giving it to this cat command. So that's how the redirection takes place. So now let's take one example. Let's clear this. Let's clear it, and then we'll take one example. Of course we have done it, or else okay, but we'll execute one more time. The first example that we're gonna take is I'll write the name, it's Vim. Okay, first let me clear the screen first. So Vim, and it is the name I will give is again it's a redirection. So redirect 1.sh. Okay, bin and then bash. So output std out will directly std out standard out or standard out redirection. Basically the standard out symbol is the one which is redirecting. So now what I want to do is ls l in tmp, in lsl of tmp should be redirected to temp dir listing .txt, and then finally after that is done, after redirection is done, it has to read do the temp listing .txt. Just let's see. So chmod and then o plus x redirection.x, and then let me execute redirect.sh. Yes, that's it. So it's been redirected, the output has been redirected, and whatever files that are there inside that temp directory, all those has been all those files has been displayed on the screen, or displayed on the monitor. This is what we wanted to have. So the next we will move on to the next thing is, we will, once std out is done, so okay, we'll just continue with the std out. Few more points to be discussed here. So with the output redirection symbol, so that's std out redirection symbol, that's greater than symbol. All the output that normally would go to the monitor is instead redirected to the designated redirection file by the shell. So you can also append data to a file. So to do this, to append the data, you do this by using double greater than symbol. So basically this exercise that we have done in our previous slide, so if you give a one symbol, whatever the file, it will completely replace the data with the existing one. So but we want to append the data, whatever is there already should be appended. It should not be completely replaced. That's what we want to do. So for that we have to use another symbol. So that is our that's the symbol. So that's double greater than. So the output generated by the, for example, in this case, the following case, if you take this example, who and then greater than double greater than symbol and then test2. So in this case the output generated uh, by the who command is appended to the data already in the test2 file. So however, if you use the standard output redirection for your script, you can run into a problem. So you can look into this the following example just to handle that, to understand what is that issue. So but before we going into the problem that we are going to get from this, so first let us do one exercise in appending the standard out, the appending the output redirection, then we'll discuss about that problem. So here we will we'll create a new file, that's vim, and then file name is std out append.sh. so bin bash, and then append the output redirection. I think mm, I have to check the file that we have created. I think it's redirection. Just let me, sorry, escape wq. So ls lrg pipeline, and is it redirection? No, I'm not sure. Let me give ls. Where is that? It's a test file. No, temp listing. That's okay. It's a temp listing. So now let me get back to this. It's a temp listing. So I will use the same file because I just want to append. We before we have we have uh, we have redirected, we have directed the output of the temp directory to this file. So now we will append that file with the who information. So who, and then that's a temp listing .txt, I guess. Then once it is done, do the echo. It's a decoration because so that it's clear. So the first activity is done, then second activity is happening, then cat, it's a temp listing .txt. That's what I want to to be mm, that's what I want to be displayed on the screen. So it's done. Let me execute it and see what's going to happen. So let me clear the screen first. uh, it's uh, okay. Before that, let me change the mode o plus x, and then file name I have given um, std out, and then it's append.sh. Yes, it's done. uh, std append.sh. Here it is. Okay, it got appended, but maybe the file name is wrong. So let me check it. There is something wrong. std out.txt. What's the name that we have given? So it's temp list. Okay, okay, the name two. Okay, it's a text, it's txt, so these are two wrong, so we lost, we missed it. Okay, temp listing.txt, we'll add the file. It's not txt, it's the text. I'll add it. Yeah, it's actually txt. I have added text. So temp listing txt, I guess. Then this one, in spite of that, I'll add uptime. Yep, that's done. So this is the directory listing of temp, and this is uptime. So let me add one more to this. One more redirection. This time what I want to add, date. Date is fine. Temp listing dot txt. Then what else I can add? Yeah, I think this is enough. Yes, now you can see the date also. Yes, so I'll add one more. See, this got added two times because again it got appended. So let me add this time ls lrt of ls lrt of which one will put home. Okay, then append to temp listing dot txt. Yeah, here it is. So existing one, then two times date, two times, and one more time uptime, and finally the finally home directory. Finally the home directory. These are the users I have: test, Surya Charan, Teja Charan, and Daksha. Okay, so the redirection part and appending the redirection part is also done. So now let's talk about the standard error. But before we go to the standard error, I would like you to discuss about one issue. So what is that? So let me take this up and bring it on right side of your screen, and let me clear the screen first. Let me write to lsl, and then I will give some random directory which doesn't exist. Only example, chavo. Okay, chavo is a random one. doesn't exist. Now I want to direct this to test.txt. Okay, now let's see. So it's saying ls cannot access chavo, so no such file or directory. So basically what is this? This is an error. So now if you put this one, we'll create a vim error.sh bin bash and then ls l chavo and redirect to test.txt. Let's see. Let me close this. Okay. chmod and the file name is error. It's error.sh. Let me clear the screen. Error.sh. So this is the output that you got. But let me check the test.txt cat test.txt. Nothing is being stored in cat test.txt. So that is the issue. So let me go to the script again. Sorry, vim. Yeah, here I will add concatenation part cat test.txt. Okay, so whatever is there, yeah. Okay, so let me clear the screen. So once it is done, it has to whatever has been directed, output has been directed to the test.txt, that should display on the screen. That's the next command that I have mentioned. So let me execute. Nothing has been displayed, though I have put cat test.txt, because cat test.txt, it doesn't have anything. It's completely empty. There is nothing has been diverted. So only it is throwing an error. How to handle this problem? Because when you write a big huge number of a huge script which consists of 1,000 or 10,000 commands, 10,000 lines of commands, then how would you, where would you know, where would you get to know, how would you get to know that there is a file? To solve that issue, we have a standard error, std error. So by default, the std error file descriptor points to the same place as the std out file descriptor. Okay, but the main purpose of std the std is the shell handles error messages using special std file descriptor. So the std file descriptor references the standard error output for the shell. So this is the location where the shell sends error messages generated by the shell or programs and scripts running in the shell. So whatever error that has been generated, all will be sent to the stdr file descriptor. So that's the reason this is very important. So now by default, so this is where all the errors are pointed out. So this means that by default the all error messages go to the monitor display. That's it. Through by default, stdr file descriptor points to the same place as the std out file descriptor. So that means whatever error that has been thrown out, all will be pointed to the std out, and std out ultimately point out to the monitor display. That's the reason you are able to see this error here. So that's the reason from stdr to std out to monitor. Okay, so now however, as you saw in the as you saw in this example, when you redirect std out, this doesn't automatically redirect std error. So when working with scripts, you will often want to change that behavior, especially if you are interested in logging error messages to a log file. So that is the reason the std error file descriptor is set to the value 2. So this has a value, so we use that value 2. So 0 1 2, 0 1 2. So 2 is designated for stdr. So you can select to redirect only error messages by placing this file descriptor value immediately before the redirection symbol, or the value must appear immediately before the redirection symbol, or it doesn't work. It has to be put before the redirection symbol, or else it doesn't work. So this is the example. So same example, if you want to redirect, so we'll take the same example. So before this output redirection symbol, the std out, you put the value of a standard error. So same file, we'll edit it. So here I will add 2, and let's see the magic, what's gonna happen. So ls cannot access chavo, no such file or a redirectory. So cat, that's it, that's it, it's been printed, it's been stored, it's been redirected to test.txt. So that's what I'm talking about. So let me clear the screen first, and then this time we will change it. So this time we will put append symbol, so that we can get to know how many times it's been pushing in. So cat, oh sorry, run it. So second time, again I'll run it third time. So because this is directly coming from the cat test.txt command, it's not just displaying the standard error output on the monitor. It's directly coming from the, see how many times, just run it, run it, run it, run it. It's been stored, it's been redirected all the time to the cat to the test.txt file. So that's how this one would be useful in basically redirecting the standard error. So redirecting errors in data. So if you want to redirect both errors and the normal outputs, you need to use two redirection symbols. You need to precede each with the appropriate file descriptor for the data you want to redirect, and then have them point to the appropriate output file for holding the data. So this is the example that you can see. So test the information from all this, and standard error, you want to put it in test 6, and then uh, while putting all those things, if you find if you get all the data that you want to put it in test 7. So here standard error you want to put it in test 6, and normal data you don't want to put, whereas from test 6, all the output from the test 6 you want to put it in test 7, the data. So 2 is for the standard error, 1 is for the data. So finally, if you check test 7, only the data is there, whereas in test 6 you can only find the standard errors. So let me mm, get to the let me sorry yeah, let me get to the uh, my WSL and start writing a piece of code for this, and then it's redirecting test 5 as well as both. We have to attach both. So let me clear the screen first. So vim, it's std error and std out. So std out std error. So .sh, sorry, .sh. So I shabang and bin bash. So it's redirecting errors and data both together. So ls l, so test 2, test 3, and then bad test. So I do not know how many files we have in that. I think test 2 we do not have, test 3 we do not have, only test we have. I don't think I have that also, but still let's do that. Okay, then if there is a no, only errors should be pushed, if actual data should not be pushed. That's how that's what the redirection we have mentioned, that should be pushed to test 6. So now the test is the whatever data that is there in the test 6, that should be pushed into test 7. So that's the reason we have used one symbol and then test 7. Okay, so now let's sorry, let's add some decoration around the concatenation of the cat, displaying the uh, displaying the uh, displaying the data from the files. So first we will read from test6 file, then echo, sorry, echo I hope you're liking my decoration. Then I really liked. Then cat test 7, then echo, decorate again, but this time it's closing session, and then a line. So let's see what is going to happen. Chmod o plus x and std out error.sh, and then std out error.sh. Here it is. Here it is. So all that it can save is no such file or directory exists, because so lsa lsl so test and test2, that's it now. So before that, let me create some sample files from, so okay, touch, sorry, touch and test 1 to 5, that's it. So ls l grep test. Yeah, so we have some tests here. So now let's go to the our file back, and then what I want to add here is lsal also. Okay, so now let me close it and let me run it and see. Okay, but this time in first file test6 you have only standard error has been stored, whereas in other file, in the other file, that's a test7 file, in that the directories from the test 6, from the initial one, has also been pushed. So this is how the number 1 and number 2 symbols helps us individually handling standard error and standard output. So then we will move on to redirecting the output in scripts also. So far we are doing that, but still, so you can use the standard out and standard R file descriptors in your scripts to produce output in multiple locations, simply by redirecting the appropriate file descriptors. So there are two methods for redirecting output in the script. So one is temporarily redirecting each line, that is the one way, and the second one, very most important one, permanently redirecting all commands in the script. So for that, first let's look into the temporary redirection. So if you want to purposefully generate error messages in your script, you can redirect an individual output line to stdr. So you just need to use the output redirection symbol to redirect the output of the output to the stdr file descriptor. So when you redirect to a file descriptor, you must precede the file descriptor number with an ampersand. So that's what. So here you can take this example. So in this example, cat test it. So testing stdr messages echo. So we just want to purposefully push an standard error messages. These are not the standard error messages, but we want to create a error message and we want to purposefully push. If you want to push it in such a way, so this is how you have to write echo. This is an error message, and forwards sorry, greater than symbol, and you have to use ampersand and then 2. So echo, this is normal output. Okay, and this is actually normal output, but we are showing a way to push the we way to push it. So this, but this is a temporary redirection. This is not the actual redirection. If you run the script as normal, you don't notice any differences because this is a temporary one. So you have to use ampersand to basically redirect user defined standard error, user defined error. So remember that by default linux directs the standard error output to the std out. We know that. And std, however, if you redirect stdr when running the script, any text directed to stdr in the script is also redirected. So let's take an example at this moment related to this. And then, so vim, it's sorry, and then this is what the file I'm talking about. So bin bash as usual, so testing standard error message. So here this is a user defined error message. So what is that? This is an error. So output a redirection, and then I used ampersand, and then number two is number two, basically it considered as std error. So when it's std error, so then finally you said this is a normal output. This is actually not a standard error message, but a user defined error message. We are pushing it as a std error message. So let me give permission x and then 13.6 and then this. So let me clear the screen, and then 13.6. Yep, here it is. This is an error. It has been printed, and this is a normal output too. So as we have mentioned ampersand, so that's the reason it's been printed as error. So now permanent redirection. If you want to purposefully generate error messages in your script, you can redirect an individual output line to stdr. So you just need to use the output redirection symbol to redirect the output to the stdr file descriptor. So when you redirect to a file descriptor, you must precede the file descriptor number with an ampersand. The same logic applies here, but in a different way. So one, so we will take this example here. I'm talking about precede this with a number 2. So we'll take an example for this also. So let me clear the screen first, and then vim. This time it is 13.7. Yeah, this is the big example we have taken. So redirecting all outputs to a file. So, and these are all permanent. The first case is exec, is a command that we have used. and you can also redirect std out in the middle of the script, so echo. So this is only for test errors, and this is also for test error. So let me come down a bit, and so finally echo, but this should go to the test error file ampersand 2. Okay. mm, let's see what is going to happen with this command at the end, because we have mentioned ampersand here, ampersand 2, we are purposefully we are pretending that it's an error, but it's not actually an error. Okay, let's do it. Chmod o plus x 13.7 and then 13.7. Okay, so one line, the command not found, I think it's redirecting that one only. So, and other than that, remaining stuff has been basically printed. So this, often while writing shell scripts, you will find yourself using the same code in multiple locations. If it is just a small code snippet, it's usually not that big of a deal. So, however, rewriting large chunks of a code multiple times in your shell script can get tiring. So, the bash shell provides a way to help you out by supporting user defined functions. You can encapsulate your shell script code into a function and use it as many times as you want anywhere in your scripts. This complete slide walks you through the process of creating your own shell script functions and demonstrates how to use them in other shell script applications. So let's begin with creating a function first. So how do you create a function? There are two formats in Bash shell scripting. You can use to create functions in Bash shell scripts. The first format uses the keyword, basically a keyword function. So along with the function name, a keyword as a function. So this is our keyword. This is a function keyword. Along with the function name, here you have to write your function name. You assign to the block of code. So then inside that, so the name attribute, basically the name that you mention here, the name attribute defines a unique name assigned to the function. So because each function you define in your script must be assigned a unique name, and then you enter your commands inside the curly braces. The commands are one or more bash shell commands that make up your function. So when you call the function, the bash shell executes each of the commands in the order they appear in the function, so just as in normal script. So now the second format, but before we go for the second format, let's have a one exercise on creating a function and then calling a function. Before calling a function, I just want to show you uh, how to create a function. So when, let's check. Yep, this is our first function. So bin bash using a function in a script. This is a first function. So function, creating a function with the first method. So here this is your function keyword, and the name of the function that I have mentioned is func1. Func1 is the name of the function, and inside that I just want to echo a simple statement that this is an example of a function, and then function is closed. Function is closed. This is what this part, the first module, is only about creating a function. So that's what we have seen so far there. So let me come down here. Yep. So now we have one more method basically to do that. The second format for defining a function in a bash shell script more closely follows how functions are defined in other programming languages, such as Python. So this is how, not exactly, but it's closer. It's closer. So you will give a function name and put parenthesis, and then whatever commands to be executed when you call that function. All commands should be placed in sequential order, one by one. Okay. So now let's look into a second kind of function creation, second type of function creation also. So when, yep, here it is. So second kind of function creation. So the name of the function, and then when I call this function, these are the commands to be executed. First one echoing a simple sentence, and then just taking up, just listing out some information from some directory. Who knows? Okay. So now we have seen different types of creating a function. But here, so once you have created the function, so after creating the function, if you think the matter there ends, no, not at all. So creating a function is one activity. So calling a function or return calling a function is another important activity. So normally we call it as a returning a value. So returning a value. So the bash shell treats functions like mini scripts complete with an exit status. So there are three different ways you can uh, generate an exit status for your functions. So the default exit status is, by default, the exit status of a function is the exit status returned by the last command in the function. So that's why it's very important point to be noted on the last command that you have mentioned in your function script, so that the exit status of that command will be considered as the default exit status of the function. So after the function executes, you use the standard dollar question mark that I have shown you in my previous sessions. You just go through it. So dollar question mark variable to determine the exit status of the function. So now the exit status of the function, one function is one, because the, so if the last command in the function fails, we'll get exit status of 1. It is non-zero. If the last command of the function that you have mentioned, if it is successful, if it is successful, then we'll get the 0 exit status code. So that depends. But before we look into those things, first let us see the let's call the functions that we have created previously in both the ways. Okay, so let's get into the WSL one more time. So this time we will look into the function again, 14 0. Yep. So this is calling the function. So once calling the creating the function. So once creating the function is done, now it's time to call the function. Okay, let's call the function. So calling the function is pretty simple. It's similar to other one. So I use a while loop here. While loop, count is 1 I have taken. If count is less than 5, so I'm going to get 5 iterations around. So 5 times it's going to call, and 5 times it's going to call the function. So that means 5 times it's going to print. This is an example of a function. Let's see, 5 times this loop is going to call the function. Not once, 5 times. Let's see. WQ chmod O plus X 14 0 done 14 0. Yes, see, I told you. This is an example of a function. So creating a function is done. Then it started calling the function. While it's calling the function, as we have used a loop, a while loop, so it has called the function 5 times. And after that, this is the end of the loop. Then these are the normal. Once the loop is end, once the loop ends, the whatever is there outside of that loop, and those also has been echoed. Those also has been echoed. So now let's also call the other function, the function which is made with the parenthesis. Okay, so vim 14 1. So yep, here is the function which is made with the parenthesis. Rest all remains same. Rest all logic remains same. So now the creation is there on top, calling the function. But this time we'll just call the function only once without any while loop. So let's, and the exit status is what we are expecting here, because the last, we have two commands. The first command, obviously, we do not have any issue. It's a simple echoing a simple statement, whereas a second thing, lsl, and we gave a directory which doesn't exist. So obviously by default the functions exit status code would be the exit status code of the last command that is present inside these brackets, inside these curly braces. Okay, let's see. Anyway, let's see what's going to happen. Let's change mode for this also. Let's 14 1. Let's clear the screen, and then 14 1. Yes, here it is. So creating is done. Now while calling the function, so it's testing the function, so trying to display a non-existent file, because there is no such file at all. So now we got an error. We got an error. So ls cannot access bad file, because there is no such file at all, no such file nor a directory. So the exit status code that we have asked, it is 2. And with this exercise, there are two things have been proven. One is the exit status code of the function is the exit status code of the last command that is mentioned in that curly braces. And second thing is that the symbol with the question mark, and then I'll just show it. The symbol with dollar and then question mark, if you give it, it will find out the exit status code in numbers, whether it is 0 or 1 or 2. Okay, so then, and finally what we'll do is we will also execute the other file that we haven't done. So one more exercise I have prepared for this. So that's vim 14 to function.sh. So here, so same thing, basically function, and then db1 is the name of the function. It's like a database for us. Then it's going to take the value from user, then it's going to double it up. Okay, so this is our function. So let's call the function. You just mentioned db1, that's it. That's more than enough to call that function. And let's check the new value here. Whenever you give a dollar and then question mark, it will find out that status code. It will find out that status code. Let's see. Chmod o plus x, and then 14 2. Yeah, it's done. So let me clear the screen first, and then, sorry, 14 2. Yes, so creating a function, while calling the function, the first activity I have to do is give a name. So I gave it. So what it said, it is red, but it's not a valid identifier. So finally what you got is an error token 2, but the new value is 1. So this is what the input it has taken. This is what the status code that we have got. Okay, so now let's move on to the using a function output and more in detail. Let's delve in detail about creating functions. So using function output, so just as you can create the output of a command to a shell variable, you can also basically capture the output of a function to the shell variable. So that's what a kind of redirection. So you can use this technique to retrieve any type of output from a function to assign to a variable. You can see that example here. So a cat test 5b, so function db1, this is the one which we have taken example. So result, so you can put the db1 or db1 result of the db whatever, you can actually assign the result or the output of db1 to the variable result. So then you can call that new value as the result. So let's do the exercise of this, and then we'll come back. Let's make it smaller this time. Clear? So vim coding 3. Yep, here is the same one, function db1, and then enter a value. So once the value has been entered, so that value should be multiplied with this 2. So that's the creation part, and after that you call that function. So you call it, in spite of directly calling it, you assign the output of this function db1 to the result, and then you call the result with the new value. Okay, so let's get out of this and then change the mode, o plus x, and then 14 3. It's done. Let's clear it off and then now execute that file 14 3. Yes, so calling the function, so I'll give you some random number that's 150. So the new value is this. So basically it's unable to print the value. Okay, test a result and it's unable to print the value. So the new function that we have, the new function now uses an echo statement to display the result of the calculation. The script just captures the output of the dbl function instead of looking at the exit status for the answer. So now let's look into one more concept in the functions. It's passing parameters to a function. So when specifying the function in your script, you must provide the parameters on the same command line as the function like this. So you just look into this following command. So function 1, and then the value 1 is a variable, and a 10 should be assigned as a parameter to that. So this function can then retrieve the parameter values using the parameter environment variable. So here is an example. The following is an example that you can see using this method to pass values to a function. So of course this is a big example. Let's directly get into the exercise and let's view that. So okay, clear it off everything. So vim and then 14 for functions.sh. So this is the big example. So this example is for passing parameters to a function. So creating a function is the first activity that we are going to do. So function, and then function name is add m. So we have a logic if whatever information, whatever value that you give, if it is equal to 0 and or and greater than 2, then you echo 1. Elif, if it is equal to 1, then echo this $1 plus $1, and then else you echo $1 plus $2. So that's what the function that we have defined. So now let's call the function. In calling the function, we have a lot of conditions. If adding 10 and 15, add them. So basically here, while calling the function, we are calling with different number of arguments. So first one is add them 10 15, so two argument. The second one is add them only 10, and then the third one just add them without values, and the fourth one is add them 10 15 20. So total four cases that we have used here, and let's see what could be the output. So chmod and then o plus x 44 and done. So let's 44. Yes, adding 10 and 15, it's 25. Let's try adding just one number, it's 20. So if you mention only one number, you'll get just 20. Now try adding no numbers, but still it's showing -1. Finally, try adding three numbers, still it's showing -1. So there's something wrong with the piece of code so that we have written. So those things can be changed, but however, in overall, the function itself is working. So now, so let's go in depth into the functions. So here we are going to discuss discuss about the array variable. So we have discussed an advanced way of allowing a single variable to hold a multiple values by using arrays. This concept is called a single variable holding multiple values are called as arrays. So using array variable values with functions is a little tricky, and there are some special considerations should be taken while using array variable in functions. So that's the reason we are specifically discussing about this concept here. So this section basically describes a technique that allows you to do that. So the first one, passing arrays to functions. Let's look into that piece of code here. Okay, so the add array function iterates through the array values. So adding them together, you can put any number of values in the my array variable, and then add array function that adds them. So this is the example that we have taken. Let's go to the WSL, and we will execute one example. So vim 14.5, sorry, yeah, here it is. So using global variable to pass a value, so we will use a array. So function gb1 here is nothing much. So calling the function, yes, here we have a enter value. So the function is pretty simple function, and then the function name is db1, and what it has to do is, this is the value. So what it has to do is multiply the values that you give with the 2, so which is not how many we are going to give. So then finally after this we have to call the function. So to call the function, how are you calling? You have to attach a value as an input to your function. So read p enter a value. So once you get the value, so then you are calling db1. Now echo the new value as a value. So let's see. Let's execute the script, and 0 14 5, yeah, then 14 5. So while calling the function, it's asking for me for number. I have gave a number, error token is 2, so I'll give 5 5. So now the new value is something. So this is how it we have entered two values. Okay, sorry. So then returning array functions, that's we have already looked into it, but you can just have a theoretical part of it. So passing an array variable from a function back to the shell script uses a similar technique. but the function uses an echo statement to output the individual array values in the proper order, and the script must resemble them into a new array variable. So here if you see the script, this is another script. So the script passes the array value. The script passes the array value using the arg1 variable to the array dblr function. You say the db array dblr function. So the array dblr function resembles the array into a new array variable. So and it makes a copy for the output array variable. So it then iterates through the individual array variables, doubles each value and places it into the copy of the array variable in the function. So, and the most important thing is my array, or the array dblr function then uses the echo statement output. So the echo statement output the individual values of the array variable values. So the script uses the output of the array dblr function to resemble a new array variable with the values. So let's get into the WSL and execute the exercise that we can do. So VM 14 and then 6, here it is. So here is the complete exercise that we have. So again the temp is smaller and then larger. Let me execute this, and then O plus X 14 6, here it is. So then 14, so you can see we have created the function that also printed and then calling the function. So the result is 22, so out of which the data that we have mentioned, out of the temp is smaller. So let's move ahead a bit. Function nodes, the most important function nodes. To efficiently and effectively handle the function, you need to know the following points, so that I want you to let know. So just focus on each and every point. I'll just run through. So you can also pass arguments to a function, and all function parameters or arguments can be accessed via a variable name preceded by a dollar symbol, either $1, $2, $3, and so on, $n. And $0 always point to the shell script name. So if you give dollar asterisk or dollar at the rate of, holds all parameters or arguments passed to the function. So dollar hash or dollar pound holds the number of positional parameters passed to the function. So array variable called func name contains its func name contains the names of all shell functions currently in the execution call stack. By default, all variables are global. So modifying a variable in a function changes it in the whole script. So you can create a local variable using the local command syntax. That's local var equals to value, or local var name, whatever the way. So you can basically create a local variable. So then before we go to the function uh, recursion, let me try to do one more exercise. Here vim 14 7 function.sh. So function tested, so local, this is what. So basically we have attached the keyword local in front of a new array variable. So then in spite of this become a global variable, it has become a local variable. So that's the reason I want to run this exercise. So then once the function tested has been created, then you can call that. So my array is this, and then echo the new original array is this. So when you mention this way, so you can all basically so normally my array takes one 2 3, when you call that, it will give you only individual number, a single number, a single a character from that array. So if you want to get all the characters or all the items of that array, so you have to give a square bracket. You have to give the name of that array and then square brackets and put asterisk at the center so that you can get all the arrays. So let's run it. Let's run it and see. Chmod o plus x 14 7 s, then 14 7. So you got this. Of course, we got some syntax error here. There is some unbroken unexpected token also. So let me check that. But I think you got the important crux of the topic that we have been discussing so far. That is, if you use a local, it's a local keyword in front of the variable, so it will become a local variable. So then we have a function, a recursion concept. So what is function recursion? So one feature that local function variables provide is self-containment. A self-contained function does not use any resource outside of the function, so other than whatever variables the script passes to it in the command line. So the the feature enables the function to be called recursively, which means that the function calls itself to reach an answer. So usually a recursive function has a base value that it eventually iterates down to. Many advanced mathematical algorithms use recursion to reduce a complex equation down one level repeatedly, so until they get to the level defined by the base value. So the classic example of a recursive algorithm is calculating the factorials. So a factorial of a number is the value of the preceding numbers multiplied with the numbers. So thus, to find out the factorial of 5, you would perform the following equation. You can see it on the screen. We have using the if then statement and then else, and then finally you have to basically give an input which number factorial you require. So using this factorial function is easy. So having created a function like this, you may want to use it in other scripts. So let's look into the script and then let's look into the script and let's run it. Vim. So this is what that a factorial script. It starts with the if then statement, and then we have converted that into the local. The variable has become a local variable, even the result variable has become a local, and then finally the result has been multiplied with this variable $1, and finally we are calling it so result in factorial. Okay, we have to enter the value. mm, 14 8 function.sh chmod. Okay,